Do you want to know how to make procedural textures in Blender, but don't know where to start? This beginner-friendly course will explain things in depth with a focus on helping you learn the important concepts through speech, visual learning, and quizzes. In this course we will cover the use of material nodes in Blender so you can apply the knowledge into your own 3D projects. I will also be using memorable analogies and visual explanations to help you remember the important details. We will take a deep dive into the basics from how to add a material to understanding concepts such as vectors and normals. Some other topics we will cover includes texture baking, different types of textures, bump and displacement, types of shaders in Blender, and more. After the core lessons are complete, we will then finish the course by making our first procedural material inside of Blender's shader editor, inspired by Shigaraki's Decay quirk from the popular series My Hero Academia. And I'll be here to guide you each step of the way throughout this course through the videos themselves, free guides accompanied with each lesson, and by answering your questions in the YouTube comments section. After completing this course, you can use your new knowledge to start creating your very own procedural textures, which you can use in your very own art projects and work. Following this course, I will be uploading more separate procedural material tutorials, which you can follow to keep your knowledge fresh and to better understand how specific materials are made. This course will be available to everyone on YouTube and comes with free resources throughout its entirety. It's also split into 3 ability levels, so if you have a bit of experience already, you can find out where to start. I'll be releasing all 13 lessons, one each day, from the 30th of November to the 12th of December. Thank you very much for watching, and I hope to see you tomorrow for the first lesson. Take care! Welcome everyone to Texture Basics in Blender Episode 1. Today we're going to have a quick overview of basic navigation in Blender, as well as we're going to create our first material using Blender's procedural node system. By default, your startup will probably look something like this when you open the Blender file. If you don't have Blender, you can click the link in my description which will take you directly to Blender's official page. There you can download Blender and follow the instructions. To navigate in Blender, we can either use the middle mouse button by holding it down and then moving our mouse to look around. Alternatively, if you're using a laptop, I find that using these ZXY axes over here, which looks like a ball when your mouse is over it, and if you move this, you can move like that. You can also, to zoom in and out, you can left click this magnifying glass and you can just scroll your wheel to zoom in and out. You can also, if you're on a touchpad, you can just left click it and then pull it back and forth. Next up we have this hand symbol which allows you to pan around the Blender 3D viewport. Now it's a tradition in the Blender community to always delete the default cube. So to do that I'm going to press A for all to select everything, then I'm going to press X to delete. Now we want to add a new object into our scene, so I'm going to press the shift key, hold it and then press A, and this will bring up my add menu. Then I'm going to hover over mesh here and I'm going to go into this menu. I'm not clicking anything, I'm just hovering with my mouse. I'm going to left click cube. Now I've added in my cube, you can see it has an orange highlighter. That means this object is selected. To select your object, simply left click it. You'll notice if you left click away from the object, it will become unselected. So let's left click it again. If an object is selected but it has a red outline, it's selected but it isn't the active object. The active object being the object which you can edit using this menu here. This menu is called the properties. With multiple selected objects, we can perform other operations together, such as going to edit mode or deleting. In this property menu here, we're going to left click on this checkered sphere down at the bottom. This is called our material properties window. Another menu that we'll be using a lot throughout this course is called the shader editor menu. This editor menu is quite a bit bigger, so I'm going to drag up my timeline here just by left clicking at the top here and just dragging my mouse or my touchpad. Now at the far left you can see a clock shape. That essentially is the symbol to represent the timeline. But we're not doing any animating today, so we're going to switch to a different workspace. So I'll left click on the clock and I'm going to come under general and I'm going to left click shader editor. As you may have noticed, both the shader editor and the material properties one have a plus new option. This does the exact same thing, and if I press plus new in one of these, you can see that both these menus have updated. This is because we're in the same object, so these are essentially different ways of altering the material. Now over here in the materials properties, you can see we've got a bunch of parameters here which we can edit to change our cube. Let's go ahead and change the base color to blue. I'm going to click on this white square here and this is going to open up my color menu. Then I can just left click and drag around and select this really deep blue color. You will also notice that in the shader editor it is updated automatically. The material properties is essentially representing this shader here called the principled BSDF. Now in order to see our material, we're going to go into another viewing. So we've got 4 viewing modes. First one is called wire. This allows us to see our mesh in a wire view. There's also a button up here called the X-ray, and what that does is allow us to see through the object. If I turn this off, you can see it's still a wire, but I can't see through it. Next up, we've got solid mode. This is the default setting in Blender. We can also use the X-ray with this one too, and as you can see, we can now see through our object. The final 2 are called the material preview and the rendered. The rendered view will give us a rough idea of how our final render will look. Material preview allows us to view our material in a manner which is much quicker than the rendered. So I'm going to click on this one here. Now you can see our blue has appeared. Great, so now we can see what our result will look like more or less when we change our parameters. Now for now, I'm just going to change my color back to completely white. To do this, I'll left click my base color in one of these menus, and I can just take the saturation value and either left click it and type in 0, or you can just drag it down. Saturation essentially controls how intense a color is, so when the saturation is 0, it can only be white or black, or any shades of grey in between. Now I'm going to quickly go over some of the parameters in this principled BSDF shader. So I'm going to left click this metallic and set it to 1, and now you can see that our surface looks a little different. We can make our metal more shiny by simply turning down our roughness to 0. This will make a mirror effect. The important thing to remember with metal is that it should only really be 0 or 1. Anything in between is kind of impossible, and there are only very few exceptions where this would be used. Roughness, however, though, we can set to any value we wish. You can see as we increase our roughness, the reflectivity gets less and less. This is because the surface is rougher, and so when the light hits it, it will bounce around more than if the material was completely smooth. Now, if we take a look in our shader editor, making sure our cube is selected if you have another object in the scene, like I explained earlier, we can edit various settings in here and it will affect it since these 2 menus are essentially synced. So I'll turn the roughness up and you can see it changes. The shader editor is brilliant because it allows us to visualize the workings behind our material in a sectioned manner using nodes. Now by default, when we created our material, it added a principled BSDF shader and a material output which determines what we see in the 3D viewport. Notice if I left click my material output in my shader editor and press X to delete, you'll notice that the cube will go completely black and it'll have no form of shading applied. So to undo that, I'll just press Ctrl and then Z. Same thing will also happen if we disconnect our shader from the surface here. To do that, we can just left click the socket and drag it out. So as you can see, that wire was connecting the 2. So I can just drag from this BSDF here and connect it to the surface. So if this is a material, then what exactly is a texture? Well, in Blender, when we make something in the shader editor, or the material's properties, we're creating a material using Blender's node system. However, a texture is an image which we can use in Blender, in the shader editor, and in other software, such as game engines. Blender also comes in with built-in textures, which we can use to create what is called a Blender Procedural texture, which is a texture created just using the built-in nodes in Blender, and not relying on external images or texture paint. To add in one of these built-in textures, we're going to open up the Add menu again by holding down Shift and then pressing A, but this time in the shader editor. Then I'm going to hover over texture. I'm still not clicking anything, just hovering, and you can see we've got quite a few textures here. Today we're just going to work with the Voronoi texture. You'll have to excuse my poor pronunciation for some of these nodes. Now, a node we're going to be using when we're making procedural textures a lot, or just textures in general, is a free add-on built into Blender called the Node Wrangler. It's super simple to add. All we're going to do is left click Edit, then left click Preferences, left click on the Add-ons tab, left click the search bar, type in Node, N-O-D-E, and you can see we've got Node Wrangler here. I've already got it enabled, but if you don't, just left click that tick box there. Then you can left click these 3 bars down in the bottom left hand corner of the menu, and just left click Save Preferences. Now I'm just going to press X to close this menu. Now, Node Wrangler has a really cool feature which allows us to temporarily view the material without permanently disrupting the material we're making. So to use this view function, I'll just press Ctrl, Shift and left click on this Voronoi texture. You can have a wee mess around with these parameters here. See, we've got quite a few options. You can mess around with these scale and randomness values, and you can see it will update the texture here. Also change the randomness to make things more uniform or random. You also notice there is a color and position circle. We call these sockets in Blender. I'm going to press Ctrl Shift and left click on the yellow one, and now we can see what the color looks like. We're not going to worry about the blue circle just now. Today we're going to be using the first one, which is distance, to create a nice circle pattern. So I'm going to press Ctrl Shift left click on the distance. If it goes down to position, just press it again. Before we make our material, I'm going to give you a couple more examples. So I'm going to press Shift and then A to open the Add menu. Then under Texture, I'll left click Musgrave Texture. Then I'll press Ctrl Shift left click on this one. And you can see we've got another type of texture, which we can use for making our own materials. I'll press Shift and then A again, and this time I'm going to add Image Texture. Now this texture is usually how we would import images to use within our material. This would commonly be used with texture bakes. We will be covering how baking works and how to do it in the next episode. To delete my nodes, I just left click them and press X. I'm going to Control Shift and left click on my Voronoi again. Now if I want to replace my base color with this texture, we very simply drag the distance and insert it into the base color socket. Now if I Control Shift and left click on the principal BSDF, you can see we've got these dots here that are affecting our metal material. I'm going to turn my metal value back down to 0, since we're not making a metallic material today. So left click it and then type in 0. Now since I'm making a kind of spotty wallpaper material, I want these circles to be a little bit more pronounced, because as you can see at the moment they're just dots with a little bit of a gradient around them. So to do that I'm going to need a little bit more control in between my Voronoi texture and my principal BSDF. So to do that we're going to use a node called the color ramp. So I'll hold down Shift then A, and under Converter I'll left click on color ramp. Then I can just drag this in between these two nodes and it will appear here. Now nothing will change straight away, but as we alter this bar here, I can just drag one of these along and you can see that's making things more pronounced. So I recommend having a play about with this. So in order to make these circles sharper, I'm simply going to left click this black slider here and just pull it towards the white one. I'm then going to drag my white value closer to the black one to create a nice bit of contrast. That should do nicely. Now another cool feature about the color ramp is the ability to actually alter the base color. So as you might imagine, the white slider here represents all the white color on this material. So if I were to change this, it would change the material where it's white. If I press Ctrl Z to undo that, I'm going to create a nice gold color for this black here. So I'll turn up the brightness and I'll go for a kind of orangey yellow color, and I'll turn down the value by left clicking on this grey slider. And I'm just going to alter it till I find something I like. So quite orangey looks quite good. So if you want to get the exact same number that I'm using, I'm going to left click on this option called hex. Now a hex code is like a combination of letters and numbers which represents each type of color in the RGB system. So you can literally type this in to your hex code and you'll get the exact same color as me. I'm now going to alter my roughness and I'm going to change it to 0.5. So left click it, then type in 0.5. Awesome, so now we've got our spotty wallpaper texture. But what if I wanted to add another material to this object? How would I go about doing that? Well, technically we could do it within this same material, but for now I'm going to show you a much easier way. So I'm going to come up to my material properties window and you can see there's a plus and a minus button. If I were to left click this minus button, it would remove this material. So I don't want to do that, so I'm going to left click the plus button. I'm also going to name my material as well, so I'll left click on my material.001 again. Might just be material for you. I'm going to left click the name here. I'm going to call it spotty wallpaper. Then I'm going to left click on my new material, which is blank just now. In fact, it's not even a material yet, it's just a slot. So I'll click plus new in one of these menus again. And I'm then going to need to assign this material to one of these faces. So right now it's a default material, which is just a white base color, and by default the roughness is at 0.5, which is just what we need. So I'm going to press tab into edit mode, and I'm going to press free on the keyboard, and this will allow me to select one of these faces. So I'm going to left click one of these faces here, left click my second material in the material's properties, then simply assign. And what that's done is assigned this material here to this face on the object. You can do this for as many faces as you want, but I'm just going to do it with one face just now. By default, you can just press tab to quickly change between edit and object mode. But I've got a special feature which allows me to change this in a more controlled way. I'm going to go back to my spotty wallpaper because I want to have the same colour as these dots on the square. So I'm going to left click my gold slider, then left click the colour here, and I'm going to left click on our hex value. This will automatically highlight it. I'm going to press and hold Control and then C, and that's going to copy it. Then I'm going to left click on my material.001, left click base colour, then under hex, I'm just going to left click to highlight, and then press Control and then V to paste. Now you can see our square is now gold. Great, so now let's review what we've learnt today. Number 1, what is a material? Number 2, what two menus did we use today to add colour to an object? Number 3, what is a texture? You can pause the video and take time to answer them, and I'll be answering the questions in around 15 seconds from now. Number 1, what is a material? A material is something we create in Blender to alter the colour of our object and add unique patterns. What two menus did we use today to add colour to our object? The first one was the material's properties window. This allowed us to make quick edits to our material. The second editor was called the shader editor. This allowed us to have more complex control over our material. What is a texture? A texture is an image, whether built into Blender or external, which we can use over multiple types of software to edit certain parameters of a shader. Today we used the Voronoi texture to edit the appearance of our base colour with the help of the colour ramp. Great job for sticking to the end of the tutorial, and if you want to leave your answers down in the comment section, I'd be happy to have a look and mark them. Also feel free to type any questions you may have about this tutorial, and I'll do my best to answer them. In the next video, we're going to cover how to bake our materials, which is essentially converting this spotty texture we've made using two materials onto a single image, which we could then use in other engines or in a new Blender file. Great job today everyone, and thank you for watching. I hope you enjoyed the tutorial, and I'll see you in the next one. Take care. So Blender, the multi-purpose software that it is, has a really handy feature: baking. So what is a bake? Well, we're not talking about making pastries in Blender here. Rather, a bake in Blender refers to converting something into a saved form. What I mean by this is, for example, if you bake a cloth simulation, Blender calculates the position of the cloth at each frame and then saves the calculation as what we call cache. This means that when we play the animation, the simulation is already calculated, and Blender doesn't have to waste resources calculating the simulation every time you play it. In terms of baking, we're talking about taking material or normal data and converting it into an image. For example, I could bake the base colour of this material and get an image that represents the material's base colour. Now, as we learned in the last episode, a texture is an image of what you want a respective shader parameter to display, and can be used in many types of software, such as game engines, and Blender of course. Whereas a Blender material is something you make in Blender and can only use reliably within Blender. Usually we make a material in Blender and then bake it so we can use it in another software or within a new Blender file without the need to append a material. So think of textures as converting a material into images. Now that sounds great, but what about this cross shape that the material has baked onto? Well, this here is called a UV, and the UV determines where the texture will be baked. This is important so the texture shows on the model how we would like it to. UVs are also a great way to make sure our resolution is the same all around the model. In order to make the UV, we want to do a process called UV unwrapping, which we will cover at a later date. Fortunately for us, cubes come with a UV made for us in Blender, so we can jump straight into baking. But first we need to see the UV. To see our UV layout in Blender, all I'm going to do is come to the top left hand corner and drag this out. Then I'll click on the top left hand corner drop down menu and change it from 3D viewport to UV editor. If you want to download this cube we made in the last episode, you can download the Blender file in the description below. Now I'm going to press tab to enter edit mode, and if I press A to select everything, you can see this cross shape I was talking about earlier. If I turn on these two arrows, it'll mean when I select something in one of these modes, it will select it in the other. So I'm going to turn that on, and I'm going to select one of these faces. And now you can see, when I've selected this middle face here, it's selected it on the cube as well. So this tells us which face belongs to which UV. As I mentioned earlier, because Blender has given us this automatically, it means we don't have to do any UV unwrapping, which is handy. So let's go about baking this texture we made in the last episode. First thing I'm going to do is I can pick one of my materials. I'm going to do my spotty wallpaper first. Then I'm just going to press Shift and then A in the shader editor. Come under texture, and I'm going to left click image texture. Then if I click this plus new, I can create a brand new image. Usually we work in 4K, but for this video I'm just going to work in 1K in order for time efficiency. I'm going to change it from untitled to base color. As you can see, I've spelt color as COLOUR. This is because I am located in the United Kingdom. If you're located in another English speaking country, it may be spelled as COLOR. Now I'll press OK, and you can see we've got a bunch of drop downs here. I'm going to keep all these the same, and we'll have the color space as sRGB. Sometimes we want to set this to non-color for other types of what we call maps. Now we've done that, we're going to click on our render properties on the top of our properties menu, and under render engine, if you're on Eevee, make sure you switch to cycles. This is because Eevee can't actually bake textures, only Cycles is capable of doing that. Down here you can see we've got samples. Since this is a bake, we can actually turn this down really low and it will hardly affect the look of the texture. However, it will render much faster. So I'm going to change my max samples on the render to 10. You don't need to change the max samples on the viewport, but for peace of mind you can easily do that. Then you'll see there's a tab here called Bake. This is where we do all of our texture bakes. I'm going to open this up, and you can see there's a drop down here where we can select what type of bake we want to do. We have all sorts of different types of bakes, but for now I'm going to click Diffuse. This is essentially going to bake our base color. Diffuse is another term usually used to refer to a base color texture. Now under Contributions, I'm going to turn off Direct and Indirect. What these are essentially the light that you may have inside your render view. So since we're just wanting to bake the color in our material, we're only going to want to have color enabled. Have a quick look and make sure these settings are the same, although they should be by default. Then all I'm going to do to bake is simply press Bake. I recommend saving before you do this. Awesome, that's our bake complete. And as you can see, it's baked our spotty texture onto this image. If I press Tab to go into edit mode, I can press A, and you can see our cross here, and if I want to see our image underneath, I can just left click this drop down here, which looks like an image with a triangle on it, and I'm going to click our base color image. Now you can see what the bake has done. It's perfectly normal to find that it will bake a little bit over the edges. Don't worry, that's not going to negatively impact the texture, that's just something Blender seems to do. If you know why this is, I'd appreciate it if you let me know in the comments below. That's great, but we're missing a square here. We're missing the square here because this is on another material. So let's go ahead and fix that. So I'm going to press Tab to go back into object mode. Then I'm going to left click on my material properties. Then if I come up, I'm going to left click on our material 1, which is the material we assigned to this square here. Fortunately, we can bake both these materials onto the one texture. So I'll press Shift and then A. Then under texture, I'm going to left click image texture. I'm going to left click on this image drop down and select base color. Now I'm going to come back up to my render properties and we're ready to bake again. Keep all the settings the same and then just left click bake. Awesome, so it's finished baking and now you can see the texture is complete. One important thing we need to do is save our texture, since this texture isn't necessarily built into Blender. So if you see up here, there's an image with a star sign. This star sign on any type of software essentially means that it's not been saved. So for example, if I saw a star beside the Blender, it means that something has changed since it was last saved. So now I'm going to left click on this image drop down and I'm going to press Save As, and then you can choose a directory to save your image. Now I'm going to create another cube to demonstrate the fruits of our labour. So I'll press Shift and then A to bring up the Add menu in the 3D viewport, and under Mesh I'll left click Cube. Then I'll press G and Y to move it along, and I'm going to create a brand new material for it. So I can come under either my material properties or my shader editor and just left click plus new. Then I can press Shift and then A, texture, then left click image texture. Then I'm just going to left click our drop down and left click our base color. Then I'm going to connect the two color sockets like this, and now you can see our texture is now appearing on here. You will see it is a tiny bit more blurry, and that's because we baked it on a 1K texture, whereas usually the standard would be 4K. So do keep that in mind if you're baking textures at lower res. Our roughness setting is already at what we want it to be, and now we essentially have the exact same cube. However, our new one only needs one material and an image, whereas another one requires two separate materials and quite a few extra nodes. So as you might imagine, this one is a lot quicker to create. So what if I want to add an image texture from a file outside of Blender? Well, all I'm going to do is left click this X here, then I'm going to press open, and a menu will open where you can find your image. If you want to try another example, I've left this gingerbread texture in the description below, which you can download, and you can try importing it into Blender if you want to practice. Otherwise you can just watch. I'm going to left click open, and then find my texture in the file browser. Now I've added my nice gingerbread texture, which I made a little while ago. I'm going to turn the roughness up on this one since gingerbread is a lot rougher. But what about textures like these? What if I'm just repeating the same image on every square of the cube? Well, to do that we're going to use a different type of UV called a cube projection. So I'm going to press A to select everything and just press H to hide. Then I'm going to press Shift and then A. I'm going to add a brand new cube. So I'm going to press plus new to add a new material. Now you can either drag and drop your image into Blender, or we can do the same thing where we press Shift A, go down to texture, left click image texture, left click open, and then just find your image. I have called this image wood base color.png. So just left click that and you can press open image when you find it. Then I'm going to connect the color to the base color, and then go into edit mode and select everything. Then I'll left click this image drop down in the UV editor, and I'm going to select wood base color. So this is the texture we are using. Now I want to make every single square the size of the texture. This will both maximize the usage of the resolution, and it will make sure our cube is scaled and rotated for each single UV square. So to do that, I'm going to press A to select everything in the 3D viewport and edit mode, and then I'm just going to press U, and this will bring up our UV mapping menu. Then I'm going to left click this option called Cube Projection. Now you can see it's turned into one big square, but these are actually all 6 of these squares stacked on top of each other. You'll also notice that some of them are rotated as well. So now we have the texture evenly distributed throughout the cube. To make sure this is working properly, we're going to use a texture coordinate. So I'm going to press Shift A in our shader editor, and I'm going to search for texture coordinate. I'll left click on that, and I'm going to drag the UV into the vector of this image texture. We will cover what vectors are in episode 4 of this course. That's great, but what if I think my wood is a little bit too small? Well, we can easily fix this. Press tab to enter edit mode, press A, then if I press S, I can scale it down. So we're going to want to work in fractions here, and I'm going to press S and then type in 0.5. Then I'm going to press tab to go back into object mode, and we can have a look at our cube. Now you can see the wood effect is much smaller. But what if I wanted to make it bigger? Well, we can do this as well. So I'll go into edit mode, select everything, then press S and then 2, and that'll scale it back up to its original size. But if I was to scale this up over the boundaries, this does work inside of Blender. Just keep in mind that you won't be able to do any texture painting or baking, and you may have some errors in other software. So I recommend always keeping the UV within the bounds of our image. So some of you might be wondering, then why was the image in the thumbnail not a single image? It's identical in each face, right? Well, actually, each one of these faces are unique, which is why I stuck with a basic cube unwrap that Blender has by default for the cube. And I also wanted to create a cool thumbnail. So some of you might be wondering, well, can we use an image to represent other parameters, such as maybe roughness, metal, or specular? Well, yes, we can. However, we're going to cover this in a later tutorial in the series, since it's a little bit more advanced. For now, we're going to wrap up the tutorial here and have a quick quiz. Number 1. What is a texture bake? Number 2. What is a UV map? Number 3. What is the difference between a texture and a material? You can pause the video to answer the questions, and I will go over the answers in 15 seconds from now. Number 1. What is a texture bake? A texture bake is an image that represents one of the parameters of our material. Today, we covered how to bake a base color texture, but there are other types of texture bakes as well, which we will cover later. Number 2. What is a UV map? A UV map is a 2D representation of our 3D object. It acts almost like a paper craft before it's turned into a 3D form. So you can think of a UV map as a flattened out version of our 3D object. This is really important for texture baking, so we can get an accurate texture to use in other software or other Blender files. Number 3. What is the difference between a texture and a material? Well, a texture is an image used to represent a certain parameter of a shader. They can be used in materials inside of Blender and in other software. A material, on the other hand, is something made in Blender, represented using nodes in the shader editor. Materials are mainly just reliable within the engine they were created in, so for example, a Blender material would only be reliably consistent inside of Blender. However, we can use a material to bake textures, which we can then use in other software. Awesome! Well done everyone on completing the second episode. If you have any questions, feel free to let me know in the comments below, and you can also comment your answers to the quiz in the comments below, and I'll mark them for you and I'll answer all your questions to the best of my ability. In the next episode, we're going to cover the types of built-in textures inside of Blender. For now though, take care and I'll see you next time. In the last couple of episodes, I explained how in Blender we have built-in textures, like these, and we also have textures which allow us to access a file outside of Blender. Today we're going to be covering these internal textures. Let's get started by setting up our workspace. I'm going to drag up my timeline here. I'm going to change it to the shader editor. So I'll left click the clock and come down to shader editor and left click. We're using a new file today, so you don't need to worry about having the file from the last episode. Now I'm going to add an object by in my 3D viewport pressing Shift and then A, and I'm going to left click plane. A plane essentially adds a square into our scene. Now I can press plus new in either my material properties or my shader editor, so I'll go ahead and do that, and I'm going to use the scroll wheel to zoom into our material. Now I'm going to add our first texture we're going to cover, called the noise texture. I'm going to come down to texture and I'm going to left click noise texture. We're now going to cover what some of these parameters mean on these built-in textures in Blender. First of all though, we need to be able to see our texture. So I'm going to plug either the factor or the color into base color. This is what the factor looks like, and to see it I'm going to go into my material preview, and this is what the color looks like. For now I'm going to plug in the factor. I'm going to focus on this. The first parameter we're going to look at is scale. Notice when I put the scale up, you'll see we'll get more and more noise. As I turn it down, we will get less and less noise. I'm going to set this back to 5. Next up we have detail. I believe each level of detail adds an extra layer of the texture at detail 0, at twice the scale as the previous layer. I'm going to quickly cover roughness as well. Roughness controls the influence of each detail layer, 1 giving each layer the same influence and 0 giving no influence to the detail layers at all. So if I was to set my roughness to 0, it would be the same as the detail being 0. So I'm going to set my roughness to 1, so our detail has full influence over our texture. So since our scale is 5, a detail of 1 is the same as adding a noise texture with a scale 5 and detail 0, and then adding a noise texture with a scale 10, also with a detail 0, and stacking them on top of each other. And for each layer of detail, I would add another layer. So if I set my detail to 2, it would be the same as adding a noise texture with a scale of 5, detail 0, a noise texture with a scale of 10, detail 0, and a noise texture with scale 20 and detail 0. So that's essentially how the detail works. Detail is really handy for creating a more rough looking texture. You can see as I increase this value, you get a more rocky, moon-like. I'm going to return my detail to 2, which is the default value. Distortion does what it says on the tin. As I increase this number, you can see our texture gets more or less distorted. It can also be influenced in the negative as well. I'll left click this to highlight it and then type in 0. 1D, 2D, 3D and 4D. So what exactly do all these mean? Well, the D stands for dimension. 1D is essentially a single value or color, and it is controlled by this W value. This essentially means when we move this W value, in this case, the grayscale value will change, as you can see, and if I were to plug in the color to the base color, when I move the W value, it will change the color. The other parameters will work in the same way, but obviously since this is just one dimension, we're limited to what we can see here. Now we're going to cover 2D. 2D will be controlled by the vector, so I'm going to press Shift and then A, and then I'm going to search for texture coordinate, and I'm going to press Shift A again, and I'm going to search for mapping. Now I'm going to plug one of these values, so I'll go for UV, and I'm going to plug this into the vector. So since this is 2D, if I change one of these X or Y values, you can see it changes. However, if I change the Z value, nothing changes. This is because this is a 2D noise texture, and so will only be affected by the X and Y vector coordinates. This of course applies for rotation and scale as well. To return all these to 0, I'm going to left click on the X and quickly drag down. Then I'll type in the number 0 and I'll reset it to 0. Also, it's worth noting, just to clarify, that everything that affects the color will affect the factor as well, since the factor is essentially just a black and white version of the color texture. Now I'm going to set the dimension to 3D. Now you'll notice if we edit the Z, you'll notice that we can now impact the texture with the Z coordinate. This is necessary for 3D objects such as a cube. I'm going to set mine to object so I can see the texture better on the cube. Factor and color. As I briefly mentioned earlier, factor is essentially a black and white representation of the color noise texture. As for how we will be using this noise texture, it's commonly used in multiple types of procedural materials. I usually use it to add a little bit of bump to my material, or to give it a bit of surface imperfection, and much more. The final dimension is 4D. 4D will use all 3 vector dimensions, but it will also have a W component. This acts very similar to the W in 1D and essentially just changes the noise value, which is really handy if you animate it. It can make it so the texture changes over time. It's worth noting though, this is not adding a 4th dimension to the vector. Another thing I want to mention is that when we increase the detail value, it's also going to increase the amount of performance power Blender needs to render the texture. So do keep that in mind when you're increasing the detail value. Think of it as more detail equals more cost of performance. I'm going to left click my noise texture and press X to delete. Next up, we're going to look at the brick texture. So I'm going to press Shift and then A, come down to texture, and then I'm going to press brick texture. I'm going to plug in the vector to the vector and the color to the base color. Now it seems to have worked alright on the plane, but not so much on the cube. Touching on what we learned in the last episode, first thing I'm going to do is change the texture coordinate to the UV, since I'm going to edit the UVs of this cube. Now you can see that's already looking a lot better, but you can notice there are different scales for each object. First thing you want to make sure that both the cube and the plane are the same scale, which I think they are, but I'm going to show you how to do it just in case. So I'm going to left click my cube first, then press Ctrl and A, and this will bring up my apply menu, and I'll left click scale. This essentially returns the scale to the value of 1 on all axes. I'm going to do the same thing on the plane, left click the plane, Ctrl, then A, and then press scale. As I suspected, this wasn't the issue, so what I'm going to do is left click our cube, go into edit mode, and I'm going to come into the top left hand corner and drag this out. Then I'm going to click the drop down and left click UV editor. Now you can see we've got our cross UV that's automatically being generated. This is great, but since we're using the same texture and just repeating it across the whole cube with different rotations, we're going to do a cube projection again. So I'm going to press U and then cube projection. We touched on this in the last episode of the series. Now you can see everything is to scale. Now I'm going to press tab and go back into object mode. You will probably just go straight into object mode when you press tab. I just have a special menu. So the brick texture is quite a bit more complicated as there's quite a few more parameters. Let's look at the colors to get started. When we change one of the colors, it will change the respective color on the brick texture. So if I was to change this to a red color, you can see we've now got a reddish brick color. And I can do the same for color 2 and make it a little bit darker. You can notice, even though we've only chosen 2 colors, we have some other variants of color in between. This is determined by the bias parameter. If I was to set this value to -1, you can see it is now only using color 1. And if I was to change this value to 1, it's now only going to use color 2. So when I set this value to 0, that's essentially saying make a mix between color 1 and color 2. And of course there'll be RGB values in between that. The mortar color will control the color of these gaps between the bricks, and this is called the mortar. So if I was to turn this right up, you can see I've now got a white mortar, but I'm going to keep it at black just now because I think that looks quite nice. Scale will control how many bricks there are on the texture. I'm going to return this to 5, which is the default value. You'll notice at 5 that everything is lined up perfect on our cube projection. So if we wanted to keep that, we would want to work in multiples. So I can just left click this, and if it was a bigger number, we could simply press shift, then press the 8 key to add a star symbol, which acts as a multiply symbol, and we could type in 2. But obviously, since we know basic math, we can just type in the number 10. And now you can see these are still lined up. To divide, we can left click this number, then we can use the /, which will act as like a divide symbol. Then we can just press 2, and now that's essentially making the fraction 10 over 2, which is the same as 10 divided by 2. And that will bring us back to 5. Again, if I wanted to make it smaller, I can maybe set it to 2.5, which is half of 5, and you can see these are still lined up nicely. I'm going to return this to 5. Mortar size will control how big the mortar is. If I press one of these arrows to increase, you can see it's gone straight away and it's made it crazy. So we're probably just going to need to add in a number manually. So it's at 0.02. I'm going to set it to 0.04, which will double it. Now you can see our mortar is a lot thicker. I'm going to turn my mortar size back down to 0.02. This number can't go lower than 0, and 0 will make it so there's no mortar at all. Offset will control the alignment of our bricks. Notice when I set it to 0, all our bricks will be perfectly aligned. And if I was to set it to 1, it will also be aligned. For now, we're going to put it back to around 0.5, which is right in the middle. Squash will control the wideness of the offsetted bricks. So notice when I increase this, only the bricks that are being offsetted will be changed. I'll press Ctrl Z to undo that. Having the squash set to 1 will make it so it's the same scale as the other bricks. Now you can see there is 2 parameters called frequency. The first one will control the frequency of the offset. So if I were to increase it, you would notice how we now have 2 aligned and then 1 offset. And if we wanted to make it 3 aligned and 1 offset, we could just increase the frequency to 4, and so on and so forth. As you might have imagined, the squash frequency does the same thing, but this is for the squash. So first thing I'm going to do is change my squash value to 2 so we can actually see the effect. Then I'm going to change my frequency to 3, and now you can see this has randomized the squash quite a bit more. So these are some great values to be aware of. Let me change my squash back to 1. Mortar smoothness will control how smooth the edges are. So right now the edges are quite hard, but if I increase the smoothness, you can see the edges become more blurry or smooth. We're going to want to keep them at its default value just now, so we'll just press Ctrl Z to undo and reset it to 0.1. The easiest ones to understand are brick width and row height. Essentially, brick width will make all the bricks wider. This is different from squash because it's affecting all of the bricks. Row height will increase the height of all the rows. So if I was to set this to 0.5, which is twice that amount, you can notice we now have twice the size of bricks. And this is why brick textures can be so useful for making other types of surfaces apart from bricks, such as swimming pool tiles or bathroom tiles, kitchen floor tiles, and wooden tiles. Finally, for the brick texture, if I plug my factor into the base color, you can see we have this black and white brick texture. This doesn't change even when we change the colors, and this kind of acts like a mask, which will be really useful. Masks are something we will cover in a later tutorial in the series, but essentially they allow us to map multiple materials or shaders to different black and white values. Now I'm going to left click my brick texture and press X to delete. Next up, we're going to add the checker texture. So I'll press Shift and then A, come to texture and left click checker texture. I'll plug in my vector to the vector and color to the base color. Now you can see we've created a checker effect. I only really use this for a basic checkered material of some kind. I personally don't use this for tiled floors or walls, as I find the brick texture is much more effective at creating the procedural texture I want for tiled surfaces. This one is essentially quite self-explanatory. Color 1 will alter the white color, and color 2 will alter the grey color. Scale will increase the scale, and factor will give us the black and white version. Notice how the black and white version won't change even if we change the value of our texture. This is just like the brick texture, where we get a permanent mask. I'm going to left click my checker texture and press X to delete. Now I'm going to press Shift and then A, texture, and I'm going to left click Musgrave texture. I'm going to plug in the vector and put the height into the base color. This is the kind of texture we've been given. This texture is really useful because it's a little bit like the noise texture, but it's unique, so good for some more variation. Unlike the noise texture, however, it doesn't have a color output. Each option in the drop down here will have a unique effect. I'm going to return it to FBM just now. Scale will increase the scale of the texture. Detail will work how we explained it earlier, so adding more scaled layers on top. However, unlike the noise texture, it seems the Musgrave texture's detail is altered by the dimension value. As you can see when I put it down low, you can see that detail much clearer. Although it's worth saying that this dimension value is different from the roughness value as far as I'm aware. So I'm going to return my dimension down to 1 so I can show you the lacunarity. If I increase this now, you can notice how we're going to get more fuzzy edges. So I'll return that back. So there's a lot of really cool effects you can get with this texture. I'm going to left click my Musgrave texture and press X to delete. Next up, we have the one we used in the last tutorial, the Voronoi texture. So I'll press Shift and then A, and then left click Voronoi. I'll plug the vector into the vector, and I'm going to display the distance. And you see we've got our spotted pattern again. You can also plug in the color. Like the Musgrave texture, you can alter these drop down menus here to get a lot of unique different looks. If I go back into distance, one common option I use is changing F1 to distance to edge. This can be really useful as it allows me to create a nice kind of crackle material. You can also change the variation of the Voronoi by changing the randomness. 0 will make things lined up, and 1 will make things completely random. Scale does what it says on the tin, it scales things up. Now I'm going to press Shift A, and I'm going to select wave texture. I'm going to plug the vector into the vector and the color into the base color. Now you can see we've got a wave effect. You can change the axes here to change the direction of the strands. You can even change it to diagonal to get a cool diagonal effect. You can also change it from bands to rings, and you can see that that alters how it looks. Scale will do what it says on the tin. Distortion will distort the lines. This can be really useful for making wood textures. You can notice this looks almost a bit like a Minecraft wooden log here. Detail will do the same thing as we explained earlier and make things look a little bit more rough. Detail scale can alter that detail even more and kind of act like a multiplier. Then we've got detail roughness, and if we set this to 0, the detail will have no influence. If we set it to 1, it'll have complete influence. Notice how detail roughness 0 is the same as having the detail at 0. Phase offset will offset the wave in a particular direction. This kind of acts like the 4D we explained earlier on the noise texture, but it does act in a different way. Finally, we're going to cover other type of texture which isn't in this node menu. We're going to have to change it from object to world. You can also access the world texture by left clicking this world icon here, and can press plus new either here or here, and now we've created a world texture. A world texture will be seen in the rendered view. You can notice if I delete the world texture by pressing X here, it will be non-shaded. I'm going to click the drop down and select our world again. This is the default, and we can change this to image texture. So I'm going to left click color here, and this is another way which we can add a texture without having to add it in the node menu. I'm going to left click this yellow dot here, and I'm going to choose environment texture. Now you can see it's added the environment texture here, and if you're in the shader mode, you'll see a massive purple display. Now if we want to add environment texture, this is where we use HDRIs. I usually get my HDRIs from this awesome free resource, and I'll have the link for it in the description. I'm just going to add one of the ones I downloaded from the website. You can simply just download one from the website, and then when you press open here, you can find it and add it. Now I've added my texture. I'm going to leave all the settings as they are. When I click on rendered view, you can see we've now got a world in the background, and this is giving it the lighting of that background. So this can be great for quick realistic lighting. But what if I don't want to see the background, but I still want the lighting effect? Well, I can change it to transparent background. So I'm going to left click render properties, then I'm going to come to film, open this up and left click transparent. And now you can see it disappears but the lighting is still applied. So that's us covered some of the built-in textures in Blender which I use the most. I'm going to have a quick quiz now to keep the knowledge fresh in our mind. Number 1. What does the distortion parameter control? Number 2. How does the detail parameter affect performance? Number 3. What texture is composed of lines by default? You can pause the video and answer the questions. I'll be going over the answers in 15 seconds from now. Number 1. What does the distortion parameter control? The distortion parameter alters the texture that makes it look like it's been stretched and scaled randomly in different places. Number 2. How does the detail parameter affect performance? As I briefly mentioned, the detail parameter, when increased, will use up more computing power. So keep in mind that when you're increasing the detail in your procedural materials. Number 3. What texture is composed of lines by default? This would be the wave texture. Great job everyone for making it to the end of the video. If you want to comment your answers in the section below, I'll mark them for you. And if you have any other questions, I'll do my best to answer them to the best of my ability. With that though, I want to thank you for watching this video, and in the next video, we're going to cover vectors, which may seem like an intimidating topic, but I promise I'll do my best to teach it to you as clearly as I can. We're not going to be going super in depth, but we're just going to cover a bit of the knowledge to help you get, at the very least, a rough idea of why they're important and what the inner workings behind it is. So with that, I'm going to wrap up the video here. Thank you so much for watching, and I'll see you in the next episode. Take care. When making textures in Blender, we use vectors in order to determine where our texture will show up on the object. Essentially in maths, vectors are like a box of numbers, the box being represented with big brackets in maths. Looking back at the dimension options on the noise texture that we covered in the last tutorial, if we were to set the option to 2D, it would only access the x and y coordinates, meaning z is as good as 0 no matter what it's changed to. 3D and 4D will have the x, y, z coordinates. 4D will also have the w to act as a fourth dimension. However, it's important to keep in mind that this is not the fourth vector dimension. As for 1D, the same applies here. Since it is controlled by a w component, it isn't controlled by the vector. Going back to a 3D noise texture, these three numbers determine the texture's position in x, y, and z, and will remain the same even when you move the object, as these coordinates are relative to the object, not to the world space. Although, if you move the object in edit mode, you will see the texture move. That's because in edit mode we are essentially moving the object within its own local space. To summarize, in Blender, a vector is a combination of x, y, and z texture coordinates. We can get these from an input node, such as the texture coordinate, or do it manually if you know how to do that. There are also 4D vector in Blender, which we will cover later. In Blender, negative and positive vectors are represented with an RGB color system. However, since negative vectors are like a negative color, which we can't see, the negative vector values are displayed as black. As for positive vectors, x, y, and z have a corresponding color. The x coordinate is represented with red, the y coordinate is represented with green, and the z coordinate is represented with blue. So, handily, it's the same order as RGB. So that can be a good way to remember it. Since it goes from x to z, it's red to blue. So that's the vector socket, but what about the color socket? Does this have anything to do with vectors? Well, yes it does. Unlike the vector sockets in Blender, all color sockets are actually 4D vectors. This means that instead of having 3 numbers in the box, like for a vector socket, the color contains 4 values. These are represented with red, green, blue, and alpha. So what happens then when we plug a vector into a color socket? Well, actually, since color socket is a vector, and vector socket, the purple one, has each coordinate represented with a color, it means it can translate into the RGB format. that the color socket has. So even though the vector socket is represented with XYZ, XYZ respectively are represented with RGB. And so when we plug that socket into a color socket, it translates perfectly since the coordinates will just become their respective color. This means that they can essentially be accurately translated into the color socket. But then what about this alpha channel? Well, since a 4D vector can't turn into a 3D vector, whenever you plug the color socket into a vector socket, the alpha channel will just simply be removed, so you don't need to worry about it influencing any of the other three values. To summarise, this means that the vector socket can go into the color socket since XYZ is represented with color, and the color socket will also add the fourth dimension alpha, but although it will be removed when converted back to a vector socket, which only has a 3D vector. To view what the vector color looks like, I'm going to use this as a chance to enable one of Blender's free add-ons, which we mentioned before, called the Node Wrangler. I'll left click on Edit on the top of my screen, then left click Preferences, and I'm just going to search for Node Wrangler under the Add-ons tab. Then I'll check the box and then left click the three bars and then press Save Preferences. Then I'll just press X to close out that menu. In order to give you a bit of a demonstration here, I'm going to change my timeline to the shader editor. Then I'm going to press this plus new here to add a texture, and I'm going to move into my material preview so I can actually see the changes I'm making. I'll left click and drag on the top of this shader editor menu to bring it up, and I'm going to left click and drag these two nodes here. Now I'm going to press Shift and A, and I'm going to use Combine XYZ, and I'm going to press Control Shift and left click on this Combine XYZ. So as you can see, since the X, Y and Z values are all at 0, that means the output will be black. But if I was to turn this X value to 1, what color do you think it will turn into? Have a guess. If you guess red, you are correct, and that's because X is represented with red. If we increase it further, it will just increase the intensity of the red to a certain degree, and then the changes become pretty much unnoticeable. I'm just going to return the X coordinate down to 0 by left clicking so it highlights and then typing in 0 and then enter. Then as you might imagine, if I set the Y to 1, it's going to become green. I'll left click and set this back to 0, and I can also left click the Z and set the value to 1, then it will become blue. You can notice if I change the values of more than one vector, you get multiple colors, and if I set all the values to 1, you'll get white. That's because all the colors added together will make white. That's great, but how else can Node Wrangler help us? Well, I'll show you just now. So I'm going to press Shift and then A, and I'm going to left click on Noise Texture. Then if I left click and drag my color into base color, and left click and drag my BSDF into surface, you can now see what our noise texture looks like. If you're confused as to why there's color here, that's because I've got the color socket into base color, whereas in the last episode we were mainly focusing on putting factor to the base color. So I'm going to return that to color. Now if I want to quickly add a vector coordinate to this, I'm just going to left click my noise texture and press Ctrl T, and you can see that's generated that mapping node and texture coordinate. So what exactly do these do? Well, there's loads of different options here on the texture coordinate. Essentially what this texture coordinate does, if I unplug it, you can see under vector, these are our vector coordinates. So these will determine how the image is shown on our object. So generated spreads the texture across the object automatically, using the vertices of the object as a reference while minimizing distortion of the image. This is something I found out on the Blender wiki, so you can go have a look and read that for yourself if you're interested. The link will be in the description. Then we've got UV. This will essentially place the image on the UV and it will be displayed on the object that way. To remind you what the UV looks like, I'm going to come to the top left hand corner, drag this out, and I'm going to left click this, and I'll left click UV editor. Then when I press tab and go into edit mode in my 3D viewport, select everything, you can see here we've got this cross shape, which is essentially the 2D version of this object. It's almost like imagining a papercraft version of this object. So coming back to our texture coordinate, when I take this UV coordinate and plug it into the vector, the texture coordinate is essentially telling the vector to use this UV here to figure out where to put each square. And you can see this in action if I press 3 in my UV editor to go into face select mode, and I left click one of these faces and drag it about. You can see it's altering rendering the image. The other one I'm going to talk about today in the texture coordinate is called the object. So if I drag and drop that into vector, you can now see when I alter my UV, there's no difference. And that's because it's not accessing the UV anymore. Rather, it's using this object texture. So what does the object texture coordinate do exactly? Well, it essentially takes the information of the object and calculates the best way to equally spread the texture across the object. However, as we briefly mentioned in the last tutorial, this doesn't really work with the brick texture. For the brick texture, you're better using a UV coordinate. But for things such as noise textures and Musgrave textures and Voronoi textures, I usually use the object coordinates. But you might be wondering then, when I bake, doesn't it only work if I use the UV texture coordinate? No, that's not true. All that's important for baking is that you have a UV in the first place. What texture coordinate you use is not related to that. It will only affect the appearance. Now we're going to move on to the mapping, which is a very useful node when creating procedural textures and for just texturing in general. So you can see we've got values for location, all acting on XYZ. We've also got rotation and scale. So if I move, for example, the X location, you can see that this face here is moving along the X axis. I can left click this and return it to 0. As you might imagine, when I left click and drag the Y, it's now going to move it along this green line here, which is the Y axis. You can see it changing. So return this back to 0. And as you might have guessed, the Z will do the same thing. So now it's moving up and down. When I left click the Z and turn it back to 0, rotation, as you might imagine, will rotate it on the respective axis. So if I was to change the rotation of this X, it will rotate the texture across this red line here, like so. Keep in mind, however, as I mentioned earlier, vectors work in the local space. So if I was to press R on my object, Z, and 90 to rotate at 90 degrees, notice if I continue altering the rotation of my X axis, it's still doing it on the same face. And that's because this object's local X-axis is where the green line is now. If we wanted to change that, we would just press Ctrl and A, and this time we would apply the rotation. And essentially what that does is returns the rotation to its default value. And now when I alter the X rotation, you can see it's now working in accordance to the global coordinates, which are represented with this green, red, and blue line here. So I'll left click this and return it to 0, and you can see when I rotate it on the Y, it'll rotate it around that green line, and you can see it's also rotating here, just like round these four faces, almost like a spinning tube. So I'll left click this and return it to 0, and Z, as you might imagine, will now rotate from the top like that, so you can see it spinning that way. I'll left click that and return it to 0. Next up we have scale. So scale is really useful. I usually use this in like basic wood textures and stuff. So for example, if I was to scale the Y, it's going to scale across this green line here, and you can see it's now getting smaller, and that will work really nicely for like a wood texture. You can also scale it on the X, like so. And now you can see we've almost got kind of a log look, and for the top two we could probably replace that with a different material. If I reset the scale to 1 by left clicking the top one and quickly dragging down and set the value to 1, if I turn this Y value, for example, down, you can see texture gets bigger this time. Although once we enter the negative numbers, it will start generating more noise again. And the other cool thing to remember about all these built-in textures in Blender is since they're mathematically calculated, we could go as crazy as we want with any of these values. Like let's say I could change my Y to like 100, and we're not losing any resolution here because it's all being calculated mathematically. So that's what separates the built-in Blender textures to like an image texture, because an image texture has like a resolution limit, so eventually it would start looking really pixelated. But since this texture is calculated mathematically, no matter how big or small we go, the resolution will still look brilliant. So that's another handy feature about the built-in textures in Blender and why they're so powerful for procedural materials. I'm now going to reset my Y value to 1, so it's now back to the default. So yeah, essentially this mapping node is an excellent way to quickly modify how our texture looks. This can also be used with your image textures as well to move it along or to rotate or scale it. Although, like I mentioned, do keep in mind that the resolution isn't infinite on an image texture. So some of you might be wondering, you may have seen in YouTube videos before, that people will use a node under the vector called bump. So this is represented with a purple socket, and it's adding normal information here. Well, we're going to be covering what normals are and the functionality of displacement and bump in a later tutorial. For now, I just want you to try and digest what we've learned today about vectors. The final thing I'm going to cover in this tutorial is the grey socket. What exactly is this grey value? If I was to press Shift and A, come under Input and then left click Value, this will give us a grey value. So if I plug this value into our vector here and I set this value to 1, it will be telling this vector here to set X, Y and Z all to 1, since essentially what the value does is it spreads the same number across all three values. So this will also work the other way around. If I was to plug a vector into a grey socket, it would essentially calculate the average, and that's what the grey socket value would become. Great, so now I've covered that, we're going to quickly have a quiz. So well done for completing this tutorial, since it is quite an intimidating one. Number 1. What node gives us a coordinate which allows us to determine how the texture is spread out on the object? Number 2. What vector node allows us to further tweak the texture's appearance on the object in an easy way? Number 3. How many dimensions does the vector socket and color socket have respectively? I'll be going over the answers in 15 seconds. Feel free to comment your answers down below and I'll mark them. Number 1. What node allows us to get a coordinate to determine how our texture is displayed on the object? The node we covered today was the texture coordinate. This will give us vector coordinate information which we can plug into our vector to determine how the texture will be spread out onto the object. Number 2. What vector node allows us to further tweak the texture's appearance on the object in an easy way? This would be the mapping, because the mapping node allows us to further tweak the location, rotation and scale values and then give us a vector output for that. That way we can make easy tweaks to how the texture will appear on the object. Number 3. How many dimensions does the vector and color have respectively? The vector socket is a 3-dimensional vector represented with X, Y and Z, which are also represented with a color, X being red, Y being green and Z being blue. The color socket is a 4-dimensional vector determined by red, green, blue and alpha. Great job everyone for making it this far in the tutorial. Next episode we'll be covering what shaders are, but with that I want to thank you all for watching and I'll see you in the next video. Take care. So what is a shader? A shader's job is to calculate how something reacts to a rendered 3D environment. Its appearance is determined by the parameters of the shader. In Blender, the parameters can be changed manually or with an image for more control. These images are known as maps, which we will cover more in depth in a later episode. For example, this is a brick texture on a cube, and this is a brick texture on a cube where the brick texture acts as a base color for the shader. You can see that the one that acts as a shader now has shading applied to it in the rendered view. Shaders can also allow you to control the appearance in other ways, such as roughness and bump. The other parameters of the shader will also be calculated based on the 3D environment to give a more realistic result. Shaders combined with lighting and a render engine can essentially simulate lighting in real life, thanks to the geniuses who developed this amazing software. So what about BSDF? What does that mean? Well, as Brilliant explained in this video by CG Cookie, BSDF stands for Bidirectional Scattering Distribution Function, and essentially means a mathematical function that controls the distribution, meaning spread of scattering, meaning scattering of light. Render engines in Blender. In Blender, under the Render Properties tab, which looks like a back of a camera, you can left click on Render Engine here, and we have 3 options: Eevee, Workbench and Cycles. We are going to focus mainly on Eevee and Cycles in this course, but essentially from what I can gather, Workbench is a render engine used to preview your models, with the advantage of being fast. However, it's not usually used for final render in things like 3D art and animation. Eevee is a real-time engine, which allows us to create a final render quickly. I usually use this render engine for animations, such as fluid sims or 3D art. This engine is brilliant, but it sacrifices some of the quality that can be achieved with Cycles in the process of gaining more speed. Cycles is the best engine in Blender for creating really nice final renders. I will usually use this for a single image or an animation if I am feeling like I have a lot of time on my hands. It's noteworthy that the render times can generally be long for each frame, which like Eevee depends on quality factors you set, such as the samples. What exactly are samples then? Well, in Eevee and Cycles cycles, we can increase the samples for a higher quality render. The sample count essentially determines how many calculations the render engine will perform while rendering your image. The more samples, the more calculations, and the more calculations, the better quality the image, as it means it gets more chance to simulate lighting. However, it's worth noting that too many samples is unnecessary and is simply a waste of your time. Changing the sample in Eevee for a final render, I find that 60 is usually enough for an animation or a single image. However, sometimes I might make a single image a little higher, but don't go overboard if you value your time. For cycles, samples used to be modified in a similar manner to Eevee, but the amazing developers for blenders made a cool new sample setting which we can set a minimum and maximum. This is great because sometimes some part of an image might need more calculations or samples to look acceptable, so setting a min and max means the engine won't use more samples than necessary for each part of the image. Think of the min and max as the maximum and minimum calculations you will allow Blender to do to make your image. This here is the minimum and maximum. You can notice we have a viewport minimum and maximum and a render minimum and maximum. The viewport will essentially determine how things look in the rendered view, whereas the render will determine how it looks like in the final render, which is when we left click this render tab, then left click render image or render animation. Also, if you have the computing power, you can set your samples for both or just the max higher. Just remember, more calculations means more render time. You can cut down on render times by changing from CPU to GPU. You can find this under device under render engine. This is only a feature in cycles. Unfortunately, my GPU is not compatible with Blender, so I have to use my CPU. However, my CPU seems to be holding its own quite well when I do my renders in Blender. Although one thing you'll need to do is enable GPU in the settings, since even if I change this to GPU compute, it won't work unless I enable it in the preferences. So I'm going to left click edit, then I'm going to left click preferences, then I'm going to come under system, and you can have a look through these different objects depending on your graphics card. You can also have a look on the Blender wiki for more information if you're stuck. I'll leave the link in the description. Once you're done that, you can just left click the three bars and left click save preferences. It's also important to keep in mind that some GPUs are not compatible with Blender. So if you're ever wanting to buy a GPU specifically for Blender, please make sure you research if it's compatible or not. The last thing you want to do is cash out on a nice graphics card and it doesn't work with Blender. Finally, we have denoise, and I recommend keeping this on for Eevee and cycles. Essentially, what this will do is remove these annoying dots called fireflies and make your image look better without having to increase the samples. This doesn't mean you can make your samples really low and rely solely on the denoiser, however, though. Rather, it's more like a bit of icing for the cake, and icing with too little cake wouldn't be very nice. So I'm going to left click on my timeline here and change it to shader editor. I'm going to left click and drag to pull this up, and I'm going to left click my cube and then press plus new. If you don't have a cube in your scene, in the 3D viewport you press shift and then A, and you can come under mesh and left cube. The first shader we're going to cover is the principal BSDF, which is essentially the ultimate shader in my opinion. I rarely use any other shaders apart from this one. It has the most parameters I need to make the shaders I want. The subsurface radius is one way to control the subsurface color. Each number here represents RGB respectively, so the first number will be red, second number will be green, and last number will be blue. You can see by default it's set to red being the strongest. I'm going to put on an HDRI so I can show the changes I'm making here. So I'm going to left click on this world option here, left click plus new, left click color, then left click environment texture. Then you can left click open and find your HDRI. I'll leave a link in the description to a cool free resource I use to get my HDRIs. Note that I am not sponsored. So right now you can see there's no real noticeable difference, and that's because our subsurface value hasn't been altered. So even if you change the subsurface radius, you won't be able to see it unless you turn up the subsurface value. This is the same for the subsurface color. Essentially what the subsurface slider does is it acts as a multiplier. If I set this to 1, it will multiply the subsurface radius by 1. This subsurface radius here will be exactly how I've typed it in when I left click this and type in the number 1. So after I've done that, you can can see it's got a kind of glowish, waxy effect. And that's essentially what the subsurface does. So you'll find subsurface on things such as skin with light shining through it and wax. And essentially how subsurface scattering works is the light will hit the object. Some of the light will go into the object where there's a different colour underneath, and that colour underneath will be shown on the surface as it bounces back out into our eyes. So if I was to change this subsurface radius, so only the top value is 1, remember the top value is represented with red, so if I set these two here to 0, once it loads up you can see we've got a completely red subsurface result. You can also notice if I change my base colour, the subsurface itself won't be affected, but obviously it will affect the result since the base colour has changed. The same would apply if I change this first value to 0. When we have 0 on all these, it won't show any subsurface, and if I set all these to 1 by left clicking and then quickly dragging and then setting it to 1, we'll get a kind of white subsurface, which is quite interesting. We can also change it to, let's say, blue, so I'll left click and quickly drag, set it to 0, and I'm going to left click subsurface radius and set the bottom value to 1, and now you can see we've got a kind of blue subsurface look. A weird thing it does is it usually starts off as a different colour, but once it finishes loading you'll see we've got this kind of blue subsurface. Now I'm going to turn this back to 0, I'm going to make my red 1, and I might turn up these other values a little bit too, like it does by default. I can't remember the exact numbers, but just a little bit tweaking will do nicely. And this is what we would usually be using for things such as skin. We can also alter this subsurface color. This doesn't work in the exact same way as the subsurface radius, but it will allow us to tweak the color further. So I can maybe set this to a more red, and now you can see we've got much more intense red. You can notice if I turn my subsurface radius to 0, but I still have a subsurface color, when I turn my subsurface to 1, you will see the subsurface color, but it won't look like really nice like how it does with the other one. I mean, I don't know the exact functionality of it, but it seems almost like it's adding like a color layer on top of the subsurface. So if you want to have a good subsurface, you should really tweak with this subsurface radius a wee bit. Usually leaving it at the default usually does the job just fine, and for most things, and you can just tweak the subsurface color here. As you can see, I've made my base color a kind of peachy color, which is quite skin-like. The reason why this looks a little bit too intense is because usually the subsurface would actually be 1 for kind of skin material, so I'd probably bring this down, and as this loads up you can see this is looking a lot more kind of skin-like. So there's a very subtle subsurface with a little bit of red coming through. So to reset this to its default, I'm just going to left click this number here and set it back to 0, and I'm going to left click my base color, and I'm going to turn down my saturation value. Saturation controls how intense the color is, so if the saturation is 0, it can only be a grayscale value. To wrap up here with subsurface, I recommend experimenting with things yourself to get a better idea how things work. For metallic, never go between 0 and 1, because a material can only be metallic or non-metallic. I believe there are very few exceptions, but I personally have never used anything apart from 0 or 1. The only exception I could think of is maybe when you're using a metal map, there may be some values that kind of slide a little bit, and I personally would only really use metallic maps that are just 0 or 1. We'll explain maps in a later tutorial. So another thing to notice about metals is if I set this metallic to 1 here, and I'm going to turn my roughness down so metals will have much more noticeable reflections than non-metals. The reason behind this is because metals are not diffused, everything else is. So you might be wondering then, what exactly is diffusion? From what I can gather in material science, diffusion is when particles pass through the tiny gaps between the atoms of an object. Metal does not have diffusion, but objects that do, what essentially that means is, like, for example, the light particles will go into the material and kind of influence how we will see it. So because metallic doesn't have diffusion, it means that it won't be as heavily influenced by the color of light as, let's say, a non-metallic object. So if I turn this metallic down, you can see we still have some reflections here, but we can also see quite a bit of color from our surrounding environment, and I believe that is what the diffusion is causing. You can also notice if I change my base color for a non-metal here to, let's say, something like red, the reflections will become a lot more noticeable. I'm not exactly sure why this is, but essentially something that's white will not not be so noticeable, but something that's black, the reflections become really noticeable, and in fact when you set it to black it almost looks metallic, although keep in mind it's not. When things are black they seem less reflective on a metal, although keep in mind reflection on all objects are the same, it's just how things appear to our eye and roughness that affects things. And you can notice if I put it back up to white, you can see our reflections much clearer. To summarise here, materials should either be metallic or non-metallic. Non-metallic materials have a thing called diffusion, which means they are affected by the surrounding light more than metals. And the last thing to notice is for non-metallic materials, the darker the material is, the stronger the reflections will appear to our eyes. So next up we've got roughness, which I briefly touched on since we're covering metals. On metals, roughness has a more noticeable change than on a non-metallic material. This is because metal don't have diffusion, meaning the material appears less rough visually. However, when the roughness of a metal is really high, it looks a lot like the roughness of a non-metallic material. So if I turn this roughness all the way to 1, it's a lot harder to tell that this object is actually metallic and could easily be mistaken as a non-metallic material by the human eye. And for non-metals on the other hand, if I change this metallic value to 0 here, you can see there's only a very barely noticeable change because our roughness is 1. If I turn this back down to 0, as I mentioned earlier, the reflections, it will be a lot more clearer to see these reflections, but not as clear as with the metal because of the effects of diffusion. For specular, using a specular map can be great for realism, but leaving the value at 0.5 will suffice for most materials. There is a way to calculate specular. This would be the calculation here, and you can use that for a more accurate option, but most of the time leaving it at 0.5 is all you'll need to do. I recommend focusing on using the roughness value to control, and I'm using quotations here, reflectivity, but how we see those reflections is determined by the roughness. So roughness is a better parameter for determining how light will interact with the surface and how the reflections will look. If you turn the specular to 0, it removes all the reflections, even though the material with a low roughness should be reflecting light. Specular is almost like an on and off switch for how light will be seen, so I recommend just not touching it most of the time, unless you want to go for some kind of perhaps stylistic look. Anisotropic is where there's loads of visible or non-visible circular lines on a metal surface. Turn this on if you want your material to look like, such as under a kettle, a CD, a DVD. The reason I say CD and DVD is although you can't really see it, there are loads of tiny little indented circular lines causing this anisotropic effect. So coming back to my scene here, if I turn my metallic to 1 and I turn on my anisotropic, now usually this would be used on a more cylindrical or circular object, but technically we can use it on this cube object. So I can just turn up this roughness value here, and now you can start seeing the anisotropic effect. So if I was to back down to 0, the anisotropic, you can see that that shading effect has gone away, and you can see this shading effect on things such as CDs and stuff like I was mentioning. So I'll turn my anisotropic back to 1. Another thing to keep in mind is this anisotropic will only work in cycles. So I'll show you what it looks like in Eevee. So here we are in Eevee and you can see we can't see the effect. So I'll go back to cycles. Anisotropic rotation will change the rotation. 0 represents 0 degrees and 1 represents 360 degrees. So if I was to set this to 1, you would see me in the same position because 360 is the same as 0. And if I was to set it to, let's say, 2.5, that would be 90 degrees. So I'm going to set my rotation to 2.5, or sorry, 0.25 rather, since the max is 1. So you can see that is moving this shading effect around. Again, this will be easier to see on more circular, cylindrical, spherical objects. So I'm going to turn my metallic back to 0, and I'll turn my anisotropic values down to 0 too. Next up, we're going to go over a thing called sheen. Sheen is great for fabrics and surfaces with very small furs/hairs. So our skin would also be an example of that if you're going for a realistic style. To help us see this better, I'm going to make this red, the base color, and I'll turn my roughness up too. So yeah, it's very subtle, but it kind of gives a fabric-y look to the material since it's kind of representing loads of little small hairs. Since using a system such as like a hair particle system would be unnecessary for loads of really tiny hairs, materials, so using this sheen would make a lot more sense. So I'll turn my sheen back down to 0. Clear coat doesn't have any applicable uses with non-metals as far as I'm aware, but it is used on metallic paint with metal in it. These are usually things found on certain types of cars, like there might be a really expensive type of car paint, in which case the first thing you would want to do is I'll turn my roughness down and I'm going to change my metallic to 1, and let's say we'll keep it red. I'm going to keep it like a red car paint. The clear coat essentially acts as a separate shader within the principled shader with a white colour and a glass-like material. So clear coat is almost like the same as glass plus principled. And finally the clear coat roughness will determine the roughness of the clear coat. So if I set this up to being quite high, now my clear coat is a lot rougher even though my main roughness value is quite low. If I turn off my clear coat, you can see that that extra roughness has kind of gone away there. And I'm going to turn my metallic to 0. Next up we have the IOR, which stands for index of refraction. I'm going to leave a resource in the description below what IOR you should use for your material. IOR is great for adding just that little bit of extra realism to your material. Next up we have transmission, which controls whether or not something is glass. So if I turn this up to 1, this becomes see-through. You can see we've got this kind of glass cube here. I'm going to change my value back to white, so I'll turn my saturation down. Now you can see we've got a nice clear glass. I can also turn this roughness value down. So yeah, that's essentially how transmission works. Transmission roughness almost seems to simulate a kind of glass density. That was the only way I could think of kind of explaining it. So when I turn this up, you can see like the inside of the glass looks a little bit more dense. So yeah, you can play around with that value to see for yourself. We're going to cover glass in a little bit more detail in episode 7, since there's quite a little bit to talk about in terms of glass. We're going to cover how to get glass working in Eevee in episode 7. So I'll turn my transmission back down to 0. Next up we have emission, and this will essentially turn our object into a light source. When it's set to black there will be no emission at all, but if I was to set this value to white, you can see it's starting to glow a little bit, and as I increase our emission strength value, you can see this gets more and more intense. Can't really see the full effects of this because there's no other object in our scene, so I'll press shift and then A, and I'm going to left plane, then I'll press G and Z to bring it down, and I'm going to press S10 just so you can see it. And if I zoom out here, you can see the effect that this cube but now light source is having. So I'll delete that. If you don't want to change the emission color, you can also just change our emission strength to 0, and that'll do the same as turning it off. Alpha will essentially turn off the object's transparency. I know I just deleted it, but I'm going to actually add another plane. I'll press G and Z, bring it down, and I'm going to press S to scale. So you can see we have some shadows here, and if I turn my alpha down to 0, you can see these shadows will disappear with the object itself. Alright, there we go. Next up we have the diffuse BSDF. So diffuse BSDF is almost like the principal BSDF, but just the roughness and the base color. It cannot be metallic and will only be able to act as a non-metal. Subsurface scattering. This one works similarly to the parameters on the principal BSDF, but doesn't have a subsurface color. So you can use the radius for this one, and the scale works in the same way as how the subsurface value on the principal BSDF works. I recommend keeping the scale low, ideally below 1, otherwise you might get some crazy results. Remember, this acts like a multiplier, so for every number of the scale you're multiplying this radius of the subsurface. Because of the seemingly fixed subsurface color, I personally find the principal BSDF easier to use for subsurface scattering because I can have more control. The subsurface scattering node also seems to produce a very slightly brighter color from my experiments. Emission. Emission does the exact same thing as the emission slider on the principal BSDF. The color represents the emission color and the strength represents how strong the light will be. So when I increase it, you can see it's stronger light. Glass BSDF. Glass BSDF is, again, it works a lot like the transmission slider in the principal BSDF. The only values you can alter are the roughness and the index of refraction, since index of refraction is quite important for glass materials. Again, if you want to see what the index of refraction for different materials, including different types of glasses, are, you can have a look at the sheet I've made in the description below, which will help you figure out what IOR to use for which respective material. Glossy BSDF. Glossy BSDF is kind of like a metallic material in a shader. You can alter the roughness value. We've got quite a smooth metal where we can see reflections. So think of this as just the metal parameter of the principal BSDF. Some people people like to use this in non-metal shaders, but I find just using the principal BSDF is much more straightforward. Holdout. Holdout essentially removes your object from the scene. The shadows will still be seen, however the object will become transparent. However, as you can see, this isn't working, and this is because our background hasn't been set to transparent. So it can come under render properties and left click transparent, and now you can see this object has now become a transparent part of our scene, but the shadow is still visible. Transparent BSDF. This shader makes the object completely see-through. Transparency can be altered here. Closer to black will decrease the transparency, and white will be no transparency. You can also alter the color of the transparency. Translucent BSDF almost makes like a partial see-through effect. I haven't used this shader much, but if you can think of any examples, I would love if you let me know in the description below. Number 1. What is the most versatile shader that I like to use? Number 2. For metallic, what values should you use? Number 3. What is diffusion and what doesn't have diffusion? You can put your answers in the comment below. I'm going to be answering the questions in 15 seconds. Number 1. What is the most versatile shader that I like to use? That would be the principal BSDF, as it allows me to create pretty much all the materials I want to make. Number 2. On the principal BSDF, what values should I use for metallic? The values for metallic that I always use are either 0 or 1. This is because a material that isn't metallic or non-metallic isn't possible. What is diffusion? Diffusion in material science is when particles pass through the atoms of an object, impacting how light affects the colour of the object. As for what has diffusion, all materials apart from metal seem to have diffusion. Well done for making it to the end, everyone. Next episode we're going to cover how to use the mix shader and add shader nodes. Thank you so much for watching and take care. In the last few episodes we've been covering textures and shaders. So today I'm going to be showing you how we can combine textures, colour and shaders. To start off, I'm going to drag up my timeline and I'm going to change my timeline to the shader editor. Then I'm going to press Shift and then A in my 3D viewport and left click plane. I'm choosing a plane so it's easy to see what changes I'm making. I'm going to left click this plus new button here to add a new material. I'll then drag up these nodes and zoom in so I can see better. Let's start off basic with how we can mix two colours together. I'm going to press Shift and then A in my shader editor, and under colour I'm going to left click mix RGB. Then I'm going to drag my colour output into the base colour of my shader. So I can see the changes I'm making, I'm going to change into the material preview mode. Now you can see a few options on this mix RGB. First one we have is the mix. This is a drop down menu which allows us to decide how we want to combine the two colours we put in colour 1 and colour 2. The factor here controls how much influence each respective colour has. In terms of mix, this will be very simple. When it's in the middle, it will be a perfect blend between the two. We can see this if I left click on colour 1 and then let's make a nice blue colour, and then colour 2 can make a nice red colour. We can see we've got a purple here since we're right in the middle, but as I bring it to 1 you're going to notice how the second colour, colour 2, will be more prominent, and the same works vice versa. If I go back towards 0, we'll be going towards colour 1. We can also change this drop down to something such as add. Now you can see as I go to, when I'm at 0 it's going to show colour 1, and as I progress towards 1 it's adding that red colour on top, which is going to give us a purple colour. I'm going to left click this drop down, change it back to mix. I'll set my value to 0.5. So you might be wondering then, well, how can we use this with textures? Just like we plug our base colour map textures into the base colour of our principal BSDF, we're going to plug our two textures which we want to mix between into colour 1 and colour 2. I'm going to add two built-in textures from Blender. I'll press Shift and A in the shader editor, then under texture I'm going to left click brick texture, and I'll press Shift A again, and I'm going to left click Musgrave texture this time. These are two quite different textures, so it'll be easy to see the changes we're making. I'll plug my colour into colour 1 and height into colour 2. Right away you can see that it's starting to mix these two textures together. These textures are acting as the colour here. Again, if I was to change my factor towards 0, you'll notice colour 1, which has been represented with a brick texture, will become more prominent, and the same will work in the other way. But what if I want to have a break texture in one area and the Musgrave texture in another area? Well, this is where the power of masks come in. So essentially what a mask is kind of like an image, which will tell where to put each texture. These are usually black and white, and if you notice how when our factor is 0, this would be represented with a black color. So wherever there's black on our mask is where color 1 would be displayed. Allow me to demonstrate. If I press Shift A, then under texture, I'm going to left click image texture. Then if I press plus new, I'm going to set the color to black and I'll just press OK. If I plug this color into the factor, it's going to tell the texture to display the number 0 across the whole mix shader. And this is because the image we've just created is completely black, and black is represented with the number 0. So using a completely black image would be the same as setting the factor to 0. If I press X here to remove this texture, press plus new, and this time I'll make a white texture, left click OK, then drag the color into the factor. Now it's going to display 1 across the whole image since it's a single white image. And now we can see our color in color 2, which is the Musgrave texture. So let's summarize what I've just explained there. Essentially, a mask is a way to control this factor value here on our mix RGB. It is a black and white image where black will determine where color 1 is and white will determine where color 2 is. Any shades of grey in between will be a blend between the two. So to demonstrate this, I'm going to use a built-in texture in Blender called the gradient texture. I'll press Shift and then A, and under texture I'm going to left click gradient texture. If you haven't already enabled it, we're going to enable the node Wrangler. So I'll left click on edit, then left click preferences. Then on add-ons, I'm going to search for node, left click the checkbox for node Wrangler, left click the three bars, and then left click save preferences. Then I'm going to close my Blender preferences window. I'll press Ctrl Shift and then left click on our gradient texture, and now we can see it in the viewport. If we want to change the direction of our texture, we would use the vector again. So with the node Wrangler, I can just simply press Ctrl T, and now we've got our mapping and texture coordinate node. I'm going to set it to object just now, and now you can see it's perfectly in the middle. When I plug this texture into the factor, have a guess what will happen. Which texture will go where? If you guessed that the brick texture would be where the black is, and the Musgrave texture is where the white is, then you would be correct. Allow me to demonstrate. I'll plug this into the factor and then press Ctrl Shift left click on the principal BSDF. Now you can see here where the white is, there's Musgrave, and on where the black is, there's mainly the brick. But you might be wondering then, well, how can I make it so it's just Musgrave on one side and then a direct cut into the brick texture? Well, there's a way we can control this, and we do this using a converter node called the color ramp. So I'll press Shift and A, then under converter I'm going to left click color ramp, and I'm going to drag that and place that in between the gradient texture and the mix RGB. By default the image will be the same, but if I Control Shift and left click on this color ramp, you can see we've still got a gradient texture here, and if I was to example drag the black across, you can see how it's now getting closer to the end. If I was to pull it all the way to the end, you'll notice it's really dominating the entire plane here. So I'll bring this back to here. If I want to bring more white across the image, I would just do the opposite, where I bring the white closer to the black, and as I bring it there, you can see we've pretty much got a cut there. I'll leave it around there just now so we can see what changes that's made. I'll press Ctrl Shift left click on the principal BSDF. Now you can see we've got a much more clear separation between the Musgrave and the brick texture. But some of you might be wondering how we can get it so it's a perfect cut in the middle, because you can see the brick texture is coming over a little bit. This is because there is still a little bit of a gradient between the white and the black. If I Ctrl Shift left click on my color ramp and I zoom in, you can still see there's a grey gradient there. So how would I remove this gradient to make this a perfect black and white? I could simply change my linear on my color ramp to constant. And now when I drag this white value, you can see there's no gradient following it. I can also make my color ramp a bit bigger by left clicking it and dragging it by one of its sides. I can then pull this white value closer like that, and that's pretty much in the middle. Then when I press Ctrl Shift left click on the principal BSDF, you can see we've pretty much got a perfect split in the middle here. You might be wondering as well, can this color 1 and color 2 be used with an external texture such as an image texture? And yes, absolutely can. So don't worry about that not working. working. I'm going to left click my color ramp, then I'm going to shift left click my gradient texture, mapping and texture coordinate, and press X to delete them all at once. Now you might be wondering, well, I want to mix two shaders together. For example, you might want to mix a glass shader with, let's say, a metal shader. So I'll go ahead and show you how to do that. So I'm going to left click and drag to box select the mix node and my textures and press X to delete. My first texture here, I'm going to make a metallic material. So I'll left click metallic and set the value to 1, turn down the roughness to about 0, and press shift and A, and I usually like to just use principal BSDF for pretty much everything. So I'm going to create another one of those. If you want, you can use my IOR sheet to set it to the correct IOR for your glass, but I'm not going to worry too much about that just now because that's more for getting a little bit of extra realism. So I'll set my transmission value to 1 and my roughness to 0. And now I'm going to add another node called the mix shader node. So press shift and then A, then under shader, I'm going to left click mix shader, and I'll add the principal BSDF. And now when I change the slider, when I move it towards 0, it's going to show the metallic material, which is this principal BSDF here, and when I move it towards 1, it's going to move towards our glass shader. In retrospect, although this is working, I'm actually going to change this to a different type of material since it's actually quite hard to see. So I'm just going to turn my transmission value to 0 on my glass texture to make it a normal non-metal surface, and I'll give it a bit of roughness. And now you can see when I switch between 0 and 1, we're going between the metal and the non-metal. Again, if I want to control this, I can use the factor here with something like a gradient texture. So I'll switch for a gradient texture, plug in the color into the factor, and now you can see it is blending between those two, like this. The metallic will be represented with the first shader and the non-metallic will be represented with the second shader plugged into the mix shader. Now we understand how we can use a mask in order to determine where each respective shader or color will go. What are some other ways that we can use the power of masks? So I'll press shift and A, and under input I'm going to left click light path, and you'll see there's all these things called rays. We're not going to focus on depth today, just rays. So what is a ray? One of these rays will act almost like a mask, but it changes based on the specific 3D scene elements themselves. You might be wondering how this works. So essentially when we plug a ray into the factor, the first shader will appear everywhere apart from where the ray specifies. The second shader will appear in the specified ray. This will make more sense as I go into the examples. So for now I'm going to left click and drag is camera ray into my factor. So is camera ray will make it so everything seen directly by the camera will appear as the second shader. So I'll press shift and A in my 3D viewport, then I'm going to left click camera. Now left click this camera icon here to go into my camera, zoom out a little bit, press N to open my side menu, then under view I'm going to left click camera to view under view lock, and then I'll just zoom out so I can see. As you can see, everything seen by the camera is being displayed as the second shader or white. So what would an example of something indirect in the scene? Well, to do that I'm going to need to set up a few more elements. So I'll press shift and then A, and I'm going to create a cube, G and X to move it. I'll press shift and D, and I'll press shift Z to move it on the X and Y axis, and I'll put it there. Then I'm going to press plus new, and I'm going to create this as a glass texture. So I'll turn my transmission to 1, roughness to 0, then I'm going to left click the other one, press plus new. For this one I'm going to turn my roughness down, and I'm going to make this base color red or something. I'll also press shift A, and I'll add, let's go for a UV sphere, G and Z to bring it up, S to scale, G and Y to move it along, G and X, left click on my cube, rename the material to glass, left click the UV sphere, right click, shade smooth, then in this drop down here I'm going to select glass. Alright, so now we've got a bit of a setup going. I'm going to go into my render view. We've got no lights or shading in our scene, so the first thing I'm going to do is in my world properties, if you don't already have one, I'm going to press plus new to add a bit of world lighting. Then I'll press shift and then A. I'm going to go in under light and I'm going to select point. Then I'll press G and Z to bring this up, and I'm going to change my strength 500 maybe even higher than that. For now that's good. Since I've got my camera to view, I'm going to go back into solid view, zoom out a little bit, I'll turn off camera to view and zoom in so I can focus on my scene here. If you want to make it so you can't see anything outside the camera, you just left click the camera, then under viewport display you can turn the passport out value all the way up to 1. Now when I left click this render button, when I'm viewing in my camera, we can only see what's in the camera. So this makes it quite easy for our scene to differentiate between the two shaders here. So I'll press G and Z and I'll bring this down, and I'll press S to scale this up, G and Z to bring it down a bit more since it's interfering with that cube, and I'll scale up a bit more. Now you'll be able to notice if I alter this base color, for example, of my first material, you can see in these non-direct view of the camera, such as these reflections in the glass, will be displayed as that metal shader that we've made. Metal was probably not the best choice of action in retrospect for this demonstration, so I'm going to turn my metallic back down to 0, and if I change my second material's base color to like yellow so we can clearly see the difference, you can now see that where the camera is directly facing, we will see the second shader, and in the indirect areas such as reflections and whatnot, we will see the first option, which is the blue. Is shadow ray is something we're going to cover in our glass tutorial. Diffusion ray will make it so the diffused light, such as the coloured shadows of an object, will be seen as the second colour. So when I plug in this diffuse ray to the factor, we can't really see anything, and that is because our plane isn't going to have a lot of diffused light on it. We swap these materials, so I'll left click my cube and call this one red, and I'm going to left click my plane and call this one example. Then I'm going to change my red cube to example. I'm going to change my plane here by just removing this material off it. And now we can see the action of the diffuse ray a lot better. So as I explained, all the diffused light will be displayed as the second color here, and everything directly seen will be displayed as the first color. So this object would be something that's kind of like directly seen, so the direct color of this will be displayed as the first shader, and the second shader will be seen in this diffused light which is on the shadow here. Normally, if I was just to plug in this principal BSDF into the surface, you would see that the diffused light will be blue in color. So this is the cool power of the diffuse ray. Is glossy ray will make it so all glossy or roughness based reflections will be seen as the second color. So if I plug is glossy ray into the factor, you can see that the reflections on the glass are all seen as yellow, even though this object is blue. And again, everything that will be directly seen will be just displayed as the first color. Is reflection ray is a cycles only feature, and it will make it so all glossy and roughness based reflections and other types of reflections, including diffuse light, will appear as the second shadow. So the difference between this and the glossy ray is on the glossy ray, notice how the diffused light on the shadow here is still blue, but on the is reflection ray, diffused light here under the cube is displayed as the second color, as well as the reflections. But interestingly, these things in blue are actually seen through the glass, if that makes sense. So that's why they are displayed as blue, since is reflection ray will not have transmission like in the glossy ray. Now, is singular ray. I couldn't figure out exactly what this does. You can see I can't notice much difference between the singular ray and the glossy ray. If anyone knows the exact difference between these two, I would really appreciate it if you let me know in the comments below. It's also worth noting that the is singular ray is a cycles only feature. Is transmission ray will make it so everything seen through glass will be the second color. This is also a cycles only feature. So when I plug my transmission ray into the factor, you can see that everything that's seen through glass will display as the second color. This also happened in the is glossy ray, although there were also the reflections were converted to in the is glossy ray, whereas the is reflection ray done all the reflections and not the transmission, so seen through glass. So if I move around my scene to see it more clearly, you can see when I'm looking through this glass ball here, we're seeing the cube as being yellow. But when we look at the cube directly, we can see it as blue. Since the transmission ray will not affect reflections per se, you can see how diffused light and reflections of the cube are still blue. It's only the things that's seen through glass that appears as yellow. Just to compare all these again for clarity, if I plug in my is reflection ray again, have a little think and see if you can remember what exactly is going to happen here. So if you guessed that all the reflections such as diffused light and reflections in the materials, but the transmission seen through glass will be unaffected, you would be correct. So you can see when I'm looking through the glass, we're still seeing blue, but all the reflections, such as the diffused light and the reflections in other materials, will be displayed as yellow. Is glossy ray, on the other hand, will make it so both seeing through glass and reflections will be displayed as the second colour, although the glossy ray will not show us the diffused reflections. So that's essentially what the light path does. Well then, what if I want to use multiple rays? For example, you might want to make it so we combine the is reflection ray, which looks like this, and the is transmission ray. So we can have the same features as the glossy ray, but also the diffused light being yellow. So to do that, I would use a node called the math node. So I'll press Shift A, then I'm going to just search for math. If you ever see in any videos some sort of mathematical option, such as add or subtract, just keep in mind this is the math node and not a separate node called add, since if you try to search that, you won't be able to find it. So we're going to combine the is transmission ray with the is reflection ray, and I'll plug that into the factor. Now you can see we've got the effects of both the is transmission ray, which is seeing through the glass, and the is reflection ray, which is adding the diffused light and the reflections. So hopefully that makes sense. You might be wondering, well, could I do this with a mix RGB as well? And yes, you can. Search for mix RGB. Difference between using the mix RGB and the math node is the math node will only work with the grey sockets. So this doesn't really affect us here because we're using grey sockets anyway. So think of it this way. Colour is compatible with grey sockets and colour sockets, whereas grey sockets are only compatible with grey sockets between the two. So I've plugged it in, and first it's created a bit of a weird result, and that's because we need to change it from mix to add. Then we simply turn the value to 1, and now you can see we've got the effect of both transmissions. If we want to mix between the two, we can turn it to mix, and whenever we have it set to 1, we're going to have the is transmission ray activated. Whenever it's set to 0, we'll have the is reflection ray set. I recommend experimenting with it yourself. Finally, we're going to cover another shader. This shader is called the add shader. So I'll search add shader. Essentially what this does is acts a little bit like the math add and the mix RGB function, but as you noticed in the mix shader, we don't have a drop down to change it to add. So the Blender developers just made this add shader instead, which we can plug in, and essentially what that's doing is combining these two shaders. So notice if I change these colors to blue and red, we're now going to get this purple shader. Keep in mind, sometimes when we're combining colors here, this doesn't work in the same way as colors in real life works, because we're using an RGB system. So for example, if I set one color to yellow and another color to blue to try and make green, this won't really work because we're working in an RGB system, not a real life color system. So hopefully that clears things up if you're confused at all about that. Great job everyone for making it to the end of this tutorial. We're now going to have a quick quiz to cover what we've learned today. Number 1. What does is glossy ray do in the light path node? Number 2. What is a mask? Number 3. What type of shader can the is shadow ray be useful for? I'll be answering the questions in 15 seconds from now. Number 1. What does the is glossy ray do on the light path node? Is glossy ray makes it so all reflections, excluding diffused light, will be displayed as the second colour. This is different from the is reflection ray because the is reflection ray will exclude the transmission reflections and it will have the diffused light reflections. Number 2. What is a mask? A mask is an image that we use to control where either a shader or a colour will go. Today we covered how to use black and white masks, which are used with our mix RGB and mix shader nodes. Something I didn't mention today is there's a thing called an RGB mask, which is something I'll be creating a tutorial on in the near future. The power of RGB masks are incredible when it's out. But today we mainly focused on black and white masks, where essentially the black area, which is represented with the number 0, will display the first input, so that could be the first shader or the first colour, and everything that is white, represented with number 1, will display the second input, which could be the second shader or the second colour. Everything that's grey, a shade of grey, will display a blend between the two. Number 3. What type of shader can the shadow ray be useful for? Only touched on this briefly, so don't worry if you didn't get this one. The is shadow ray is useful particularly because we can control the intensity of the shadows of the glass, since shadows on glass tend to be less intense compared to normal objects. But without using caustics, by default, the glass shadows are usually quite full, which doesn't actually make much sense. So this is why the is shadow ray can be useful, since caustics are quite performance heavy, and sometimes we have to use them with caustics, even if we do have the performance available. We'll be using this part of the light path node in the episode where we cover glass. Great job everyone for making it to the end of this tutorial. In the next episode, we're going to be looking at Eevee and cycles in terms of glass, since you'll notice that glass doesn't really work in Eevee by default. We'll also be covering that is shadow ray light path option, and also how we can get subsurface scattering to work in Eevee. We'll also be covering how to get really nice glass shadows using caustics, so it's going to be a very specific episode, but still very important nonetheless. With that though, I'd like to thank you all for watching, and I'll see you in the next video. Take care. So, you're struggling to get glass to work in Blender, whether that's a fancier shading with caustics, or your glass and subsurface scattering just isn't working in Eevee. Well, today we're going to tackle all of these issues, so let's get started. First of all, I'm going to change my timeline to the shader editor. Then I'm going to press Shift and then A to open my add menu, and left click UV sphere. Then I'll press Ctrl 1 to add a subdivision surface of 1. I'll left click my wrench icon here, which is the modifier properties menu, and change the render down to 1. Then with my UV sphere selected, I'll right click and left click shade smooth. Then I'll press Shift A, and this time I'll add a plane, GZ-1 to bring it down. Then press S to scale, and then 10, and that'll scale it by 10. Then I'll press Shift and then A, and I'll left click cube. Then I'll press G, Shift Z to move it on only the X and Y axis. This cube will be a way to check if our glass is working, and this plane will be a way to see how our shadows look for the glass. Now I'm going to come into my world properties here, and I'm just going to add a basic shading environment. I'm going to make sure I'm in the cycles render engine, and I'm going to left click my render preview. I can left click these two circles here to turn off the environment so we can just see it for what it is. I want to add a few lights into my scene. So I'll press Shift and then A, then under light, I'm going to left click area light, and I'll press G and Z to bring this one up. I'll left click this light bulb here, and I'm going to set the power to, let's say, 50. Press G and Z and pull it up a little bit more, and I'll press G Shift Z. I'm going to move it a little bit away from my sphere. Pretty basic lighting, but that'll do for now. I'm going to left click these two circles again so I can see what I'm selecting. I'm going to left click my sphere. Then in my shader editor, I'm going to left click plus new. Then to turn this into a glass shader, I'm going to left click transmission to highlight, and then type in the number 1. I'll then turn my roughness down to, let's say, 0.02. Already here in cycles you can see we're getting a nice shading effect, but we can give ourselves a little bit more control over this, since your reference may have a brighter shadow, for example. So how do we go about giving us the power to control that? Also, a quick thing I'm going to do is change my IOR to 1.511, which is the IOR for window soda lime glass, as found in my IOR guide. I'll press Shift A, my shader editor, and under shader I'm going to left click mix shader. Plug that in between the material output and the principled, and I'm just going to zoom in so we can see things a little bit better. I'll press Shift A again, then under shader I'm going to use the transparent BSDF. Now if we remember from the shader video, when the transparent BSDF color is white, it will be completely see-through, and when it is black it will be completely opaque. So this is how we're going to control our shadow. As you can see, Blender can't differentiate between the shadow and just the glass. So to fix that, we're going to use the light path we didn't use in the last episode, and that's called the is shadow ray. So press Shift A, then in input I'm going to left click light path. Left click to place it, and I'm going to drag out is shadow ray into the factor. Now by default, since our transparent BSDF is set to white, our shadow is going to be completely transparent, and as I bring it closer to black, you can see we can make our glass shadow a little bit darker. So this can be great because now we have a control over how dark or light our shadow is, so we can better match it to our reference image. Option 2. For option 2, we're going to be using Blender's caustics. These will give us a slightly more realistic shadow, although it is more demanding on performance. So for now, I'm going to drag my principled BSDF and plug it into the surface. Then under my object properties, I'm going to scroll down and And under shading, I'm going to open up this window, then on caustics, keep in mind I've got my UV sphere selected while I'm doing this. So I'm going to left click cast shadow caustics, because this is an object that's going to cast the caustic effect onto the plane. So then the plane will left click that, and we will left click receive shadow caustics. But you'll notice that it's still not working, and that's because we need to set our area lamp to caustics. So I'll left click the bulb and turn on shadow caustics. And now you can see quite a drastic change has been made. This is what Blender has determined would be the result with caustics. And the good thing is about this other shader we've made, if I plug my mix shader back into the surface, I can tweak the color of the shadow even further. So these two can be combined together or used separately. Just keep in mind that caustics are quite performance heavy, so you'll want to be careful while using them. I'm going to plug my principal BSDF back into my surface. Now I'm going to left click my render properties and I'm going to change into Eevee. Straight away you can see we've got a big issue. We can't see through the glass. Since Eevee seems a little bit darker here, I'm going to left click my area lamp and I'm going to change my power to 100 in the light bulb settings. There we go, much better. To get our glass to work in Eevee, we're going to need to turn on a few different options. First, in my material properties window, which you can find here, is this red checkered sphere. I'm going to scroll down and I'm going to left click screen space refraction under settings in my sphere. Then what I'm going to do is left click on my render properties and I'm going to turn on screen space reflections and turn on refraction. Now you can see we can see through the glass. Keep in mind this won't look quite as good as it does in cycles, and that's simply because Eevee isn't as good at handling glass. I can also turn off half res trace, turn up my trace precision to make it a little bit better. I can also turn on some other Eevee improving settings like bloom, ambient occlusion. I'll turn my ambient occlusion distance to 1, and I can also turn up my shadow size. So if I'm doing a really nice render, I'll put this all the way up to 4096. Just keep in mind the higher you set these two, or especially the cascade size, the longer render times will be. So for now, I'm going to keep this at 1024 pixels and I'm going to set cube size to that as well. I'll also turn on high bit depth shadows, and you can also turn off any kind of soft shadows by simply pressing this. I'll put that back on though, and this is great, but we can see that our shadow is a little bit too bright. So we can just simply plug in our mix shader back into our surface, and now the power to control this has been returned to us. But something's wrong. Even when we're changing it, we're noticing no real noticeable difference, and that's because we need to change another setting on our sphere. So I'll left click on our render properties and I'm going to change our shadow mode to alpha hashed. You can also change it to alpha clip, that seems to work. I'm not very knowledgeable on these shadow modes, but I found that both alpha hashed and alpha clip work fine. And now when I change my transparent BSDF color, you can see I can now alter how bright it is to make a more realistic shadow for our glass. Again, I would recommend referring to a reference in order to make sure you get this right. You could also, if you wanted, alter the IOR to something less realistic in order to get a glass result you're more happy with. But for cycles, I would always recommend sticking with the most realistic option, which for us is 1.511. I'm going to left click this material.001 and I'm going to call it glass. Awesome. Now I'm going to left click this X and I'll press plus new. For now I'm going to go back into cycles, so I'll left click Eevee and change it to cycles. I'm going to leave my subsurface radius as it is and I'm going to put this up to 1 just so you can clearly see the effect. Now as it's loading up you can see our subsurface effect, and I might even change our base color to a more kind of peachy color just for example. Now you can see in cycles our subsurface scattering is working nice and fine, but what about Eevee? Well, if I change, straight away you can see we still have a little bit of subsurface here, but we can definitely improve this. First of all, I'm going to leave all these settings as they are. You can also alter the subsurface scattering here. Turning up the samples, I believe, will just turn up the quality. Then in my material properties here, I'm going to scroll down and I'm going to turn on subsurface translucency. And now you can see we're getting a better subsurface scattering result in Eevee. Great, that's us finished. Well done for following this tutorial. I know it seemed like quite a simple topic, but I feel like it was important to cover since you're bound to encounter these issues at some point in your 3D career. Now we're going to have a quick quiz. Number 1. What method can we use to control how bright or dark the glass shadows are? Number 2. What settings do we need to enable for transmission seeing through glass to work in Eevee? Number 3. What options do we need to enable to allow caustics to be displayed? I'll be answering the questions in 15 seconds from now. Number 1. What method can we use to control how bright or dark the glass shadows are? For this, we use the light path node, a mix shader, and the transparent BSDF. On the light path node, we used the isShadowRay and plugged it into the factor. This allowed us to use the transparent BSDF to control how bright or dark the shadow is. If we set our transparent BSDF to completely white, our shadow would be completely invisible, transparent. And if we set it to black, it would be completely opaque. Number 2. What settings do we need to enable for transmission to work on Eevee? To do this, we first need to go into the material properties of our glass material and turn on screen space refraction. Then in our render properties, we need to turn on screen space reflections, turn on refraction, and optionally you can turn off half-res trace for a more accurate result, or better looking result. Number 3. What options do we need to enable to allow caustics to be displayed? First of all, in our object with our glass material on it selected, we go into the object properties, making sure we're in cycles since caustics is a cycles feature, and we'll turn on cast shadow caustics. And we'll turn on cast shadow caustics, which means that this object will be casting the caustics effect since it's the glass. And we'll do this for all our glass objects. For all the objects that will have the shadows hitting it, such as the plane, our example, we would want to do the same thing but turn on receive shadow caustics and leave cast shadow caustics turned on. Finally, we'll left click on our light source, which you may have multiple of, and in our object data properties, which on the light source looks like a light bulb, we turn on our shadow caustics. We can also combine this method with the method we touched on in the first question in the quiz in order to have further control over how our shadow looks. Great job everyone for completing the quiz. If you want to let me know what your answers were, you can type them in the comments below and I'll mark them for you. If you have any other questions about this tutorial, feel free to ask me and I'll do my best to answer them to the best of my ability. In the next episode, we're going to be covering what maps are, such as Roughness Map, Diffuse Map, and Normal Map. And yeah, thank you all so much for watching, and I'll see you in the next episode. Take care. So, what is a map in 3D? A map is an image texture used to represent a certain aspect of a shader. For example, for this texture, the base color map will plug into the base color, making the base color of the shader the image. Note that maps are usually designed to work with the UV vector output from the texture coordinate. Since this is a single image and we want to place it on our cube, we will use a cube projection, which, as mentioned earlier in this course, will scale up and rotate each face of the UV to map the repeated texture on the cube. You might also find a map with the name Diffuse or Albedo. These will likely be for the base color as well. This here is a roughness map, and as you might imagine, this gets plugged into the roughness value. But how can a black and white image give us roughness? Well, if we look at the slider, roughness can be set between 0 and 1. What's really useful is that any number for a grey socket has a black and white value counterpart. In Blender, 0 represents black and 1 represents white. This means that all the darker parts of the roughness map will be closer to 0, which is very reflective, and all the brighter parts will be closer to 1, making those areas less reflective. A gloss map is very similar to a roughness map. However, since Blender works in roughness and not gloss, we have to invert the texture in order to convert it to a roughness map. Since unlike a roughness map, the gloss map will have it so the more reflective areas are represented with white rather than black like they will be in Blender. To do this, we simply press Shift A, then search, and we're going to search invert. This will give us the invert node. When we plug this in between the two, we've now inverted the glossy map, which will make it work as a roughness map. You can also get maps that can represent metal and specular. Just like with the roughness map, 1 represents white and 0 represents black for all non-color maps. For example, this metallic map, the black represents a part of the image which isn't a metal, 0, and the white represents the part that is, 1. This is the same for bump and displacement maps, which we will cover in episode 10. You can get all sorts of maps. Some more or less known ones will require a little bit of extra research to figure out how to use them in Blender. Another map you will often find is a normal map, which is very useful as it can be used to add free detail without the cost of resources. It's similar to the bump, but not as detailed. Normal maps can be seen by their purplish blue appearance. But how can we make a normal map? Well, there's two ways, which I often use. The first one is baking a normal texture from my procedural material. This will take all the normal information, which can be determined by a bump node, for example, and I'll use that to calculate what the normal map will look like. The other way is by baking the detail of a higher poly detailed object onto a symbol object. I'll make a step-by-step tutorial in the future on this topic. Great job everyone. This was quite a quick tutorial compared to the others, but still very important nonetheless. Now we're going to have a quick quiz. Number 1. What is a map? Number 2. What option should you make sure is on when baking roughness or normal maps? Number 3. What grayscale values represents values 1 and 0 respectively? I will be answering the questions in 15 seconds from now. Number 1. What is a map? A map is an image texture usually used to represent a parameter of a shader. For example, a base color map would be used to represent the base color of a shader, whereas a roughness map would be used to represent the roughness parameter. Number 2. What option should you make sure is on when baking roughness or normal maps? In order to ensure there are no errors, I always recommend enabling non-color. To do this, we change this drop down here to non-color. Number 3. What grayscale values represents values 1 and 0 respectively? Value 1 is represented with white, whereas value 0 is represented with black. Any grayscale values in between will be represented with a decimal number in between that. Great job for completing the quiz everyone. In the next episode we're going to be learning all about normals and what exactly they are. This is a really good fundamental topic to cover for 3D software in general, so I hope you will enjoy it. Thank you so much for watching, and I will see you in the next video. So what is a normal? Well, to explain what a normal is, we're going to take a look at this cube. Every face of any mesh has a direction, and this is called a normal. A normal refers to the direction a face is pointing relative to itself. So ideally, I want all of my normals to be facing outside in Blender. If the normals are facing outside, like they should be, they will be represented with a blue line or a blue face. In our 3D viewport, if we want to set up the ability to see our normals, the first way is to use a colorway of seeing our normals, where blue will mean that the normals are facing outside and red will mean they're facing inside. On this cube, we want all the normals to be facing outside, since we're seeing the outside of the cube. So under my overlay tab, these two circles, there's a drop down arrow, and underneath a left click face orientation. And now you can see by default all the faces are blue. If I zoom right into this object and clip through it, you can see inside the cube the faces are red, and this is because they're the inside facing normals. Another way we can see normal direction is by going into edit mode, and we can enable this option down here for normals. You can see we've got a few different types, and we're going to want to click face, which is this third option here. And now you can see there's these blue lines pointing out. This means that normals are facing outside. If I were to press A to select all the faces, then left click mesh, normals, and press recalculate inside, now you can see those blue lines have disappeared and our faces are now red. And this is because the outside of the normals is now the wrong way around. I'll press Ctrl Z to undo that. If the normals are facing inward like this, they are called flipped normals. Normals facing the right way or outside is important for a few reasons. First thing is it can cause shading issues if the normals are not facing outside. As well as that, you can also experience issues with certain types of modifiers and normal data on your material. So how do we fix flipped normals? If I come back to my cube and I'm going to go to mesh, then normals, recalculate inside to make sure the normals are the wrong way around, and you could do this even if only some of the faces were facing the right way. So let's say for example I left click one of these faces and left click mesh, then normals, and then I do recalculate outside. You can see this face is now being returned to the right way around. You can also press A to select everything and press Shift N, and that will recalculate everything we have selected. So essentially you want all these faces to be blue and to have one of those blue lines if you have that option enabled. And this should fix up a lot of shading issues and stuff you may be having with your model. When I'm modeling, I may stop and recalculate the normals outside if I feel like experiencing some shading issues. Blender is really good at recalculating normals, but in the off chance that Blender misses a face, we can click on it and then click recalculate inside, since essentially what that'll do is flip it no matter what. So you might be wondering then, how exactly do normals relate to normal maps? Well, if we look at a normal map, There are various colours, mostly bluish and reddish colours. Normal maps work in RGB, and like we've covered previously in our vectors video, RGB represents X, Y, Z respectively, red being X, green being Y, and blue being Z. So since normal maps hold RGB info, that info can be used as vector info, stored as XYZ, since RGB and XYZ can translate to one another. As some of you might have figured out, this is why normal info uses the bluish purple socket. When we apply this normal map to the cube, it will alter the shape of the normal at a small pixel level. So each face for this unwrap will alter its respective face on the geometry by rotating and moving the normal around at a pixel level. This creates the illusion of more geometry, but it's actually just one face with its normal altered at a pixel level. So each pixel will have a vector with a RGB/XYZ. This vector acts like coordinates to determine each pixel's orientation. I like to think of a normal as being able to be deformed like Play-Doh into a unique detailed normal, and to control this deformation we can use a normal map or some sort of normal input. For example, this bump node, essentially what's happening is it's translating bump info into normal information. We will cover bump in greater detail in the next episode. What makes normal information even more amazing, whether that's through using a bump node or a normal map node, is that the altered normal will react to light and material changes, just like a modeled geometry, even though this face is just 4 vertices. It's also worth noting that there are 2 main types of normal maps. These are OpenGL and DirectX, although keep in mind that different types of 3D software will have a different default normal map. So in Blender, we use OpenGL by default, which means if we have a DirectX normal map, we have to do an extra step in order to make it work in Blender. Fortunately, this is fairly straightforward. As always, we're going to make sure our normal map is set to non-color in the color space. Then I'm going to press Shift A, then under Converter, I'm going to left click, Separate Color. This used to be called Separate RGB, so that might be what it's called in your version. Then I'll plug my color into the color, and now I'm going to press Shift A, and I'm going to search for Combine, and I'll left click Combine Color. Now we're just going to connect the red to the red, blue to the blue. I'm going to leave the green just now, since the difference between DirectX and OpenGL normal maps is DirectX normal maps have a flipped green channel compared to OpenGL. Also, like we do for any normal map, we will need the normal map node. So I'll go into Vector and left click Normal Map. I'll leave the strength at 1, and I'll plug my normal into the normal of my shader and color into my color. Then in order to get this DirectX normal map to work, all I'm going to do is press Shift A, and I'm going to search for Invert. You'll notice that the invert is a color socket, which means we can invert color channel. Then I can plug my green into color and color into green. And now we have inverted the green channel and essentially turned this DirectX normal map into an OpenGL compatible normal map. Finally, I'm going to cover what Shade Smooth is, also known as Phong shading. So essentially what Shade Smooth does is it averages out the normals. So if I take my cube here, go into object mode and press right click and Shade Smooth, you can see it creates this weird effect. And that's because it is averaging out the shading of the normals. You may have heard before, or heard myself mention this, but if we come down into our green triangle here, then under normals, left click auto smooth, that fixes things up. And that's because we've now set an angle limit, which essentially makes it for if the angle is 30 degrees or more, it won't shade smooth. If I right click and subdivide this cube and turn up the subdivisions a couple of times, and I'll select this face here and press O to turn on proportional editing, then press G and X to bring this out, you can see when I go back into object mode that this thing has been shaded smoothly. Although if I was to lower my angle, eventually it would start shading flat again. And that's because these angles are around 5 degrees or less. So I usually keep this at 30, but it's good to know how this auto smooth function works. Since we're essentially averaging out the normals here, if I was to press Shift A and add another cube and right click and shade smooth, you'll notice that the shade smooth will fix itself. If I was to, for example, bevel all these faces here, you can see how much better that looks now. Then we would essentially be improving it more and more by adding loops and more geometry, since each one of these faces will be taken into consideration when calculating the shade smooth. Now we're going to have a quick quiz. Well done for completing the tutorial so far. Number 1, how does shade smooth work? Number 2, how do normal maps alter the normals of the mesh it's applied to? Number 3. How can we visually see if normals are facing the right way? I'll be answering the questions in 15 seconds from now. Number 1. How does shade smooth work? By averaging out the normals and smoothing it out that way. We can also use the auto smooth function to limit the angle where shade smooth will be applied to. This is really useful because on a cube, for example, we wouldn't want to have these faces smoothed out since the angle is really high and it wouldn't make sense for it to be smoothed out. So we can turn on auto smooth, which will make it so any angle bigger than 30 won't be smoothed. Number 2. How does a normal map alter the normals of the mesh it's applied to? A normal map will alter each normal of the face at a pixel level, and this will be determined by the normal map we plug it into. Cool thing about this is lighting and materials will affect this normal effect as if it were modeled geometry, which makes normal maps really powerful. Number 3. How can we visually see if our normals are facing the right way? The first way to do this is to enable the colored faced orientation in this drop down here in either object or edit mode. The second way is just in edit mode, where we enable our normal direction blue line here, which will show us if our normals are facing outside or not, since we need our normals to be facing the right way in order for our shading and certain modifiers to work properly. Great job everyone for completing this tutorial. In the next episode we're going to be covering displacement and bump in a little bit more detail. Also, if you want to write down your answers to the quiz or you have any questions for me about this tutorial, feel free to let me know in the description below. With that though, I would like to thank you all very much for watching, and I'll see you all in the next tutorial. Take care. The bump node and displacement node are great nodes to use in order to add a bit of depth to your material without having to do any modeling or sculpting. First up we have the bump node. In order to add a bump to our material, we will need to use a height map and plug that into the height parameter. We can also do this procedurally. For example, we could use a noise texture to add a bit of height. Once we've got height on our bump node, we will plug our normal into the normal parameter of our shader. What essentially this bump node does is it will translate this height information into normal information, so it can be displayed on the object as edited normals to look like a more complex geometry than it actually is. I usually leave the distance at 1, but the strength here can be tweaked in order to control how much intensity our height map will have. If I set my strength all the way down to 0, our height map will be as good as invisible, and when I set it to 1, it will be fully visible. Finally, we have the invert, and this works very similarly to the invert node. And when we left click this checkbox, what is currently protruding will now appear as indentations. So just to recap, a height map is a black and white texture that is commonly used with a bump and displacement nodes and modifiers. With a bump map, it will be converted into normal information, which will alter the normals, altering the appearance of the object. With a displacement node, it will alter the vertices of the mesh itself. As we covered in the maps tutorial, the shades between white and black will have a numeric value between 0 and 1. Completely black is 0 and completely white is 1. So this means for bump and displacement, the white areas will be protruding, whereas the areas that are black will be indentations. Coming back to our bump node here, we might want to add multiple bumps. For example, in our final project, we're going to have surface imperfections for the brick and a protrusion of the bricks themselves. So to do this, we would need to do 2 bumps on one shader. Thankfully, this is very simple to do. All we would need to do is press Shift A, add another bump node, then we can set up our bump node by connecting our height map, and then plug the normal into the normal of the other bump. And essentially, it will just carry on this information to the next bump node. Keep in mind, when we alter the strength of the last bump node, it won't impact the bump before it, since it's stored in this normal channel here, which won't be affected by things like the strength or the invert. So think of it as all these settings apart from the normal are exclusive to the specific node, whereas normal input information will not be changed. Before we cover displacement, we're going to need to set up a few settings. First of all, I'm going to create a quick material. So with my cube selected, I'll press plus new, then I'll press Shift A, and I'm going to search for displacement. The displacement node will just plug into the displacement of the material output. By default, when we're using our displacement node, it will act almost a bit like a bump, but we're wanting to use our displacement to the full effect. So I'm going to take my height map that we used in the bump example by just adding an image texture, pressing open and finding my image, and I'll change my color space to non-color, press Ctrl T, make sure we're using the UV coordinate, plug my color into the height, then in the 3D viewport, I'll press tab, enter edit mode, A to select everything, U, smart UV project, change your island margin to around 0.3. Straight away you can see our bump effect, but this isn't using the full effect of displacement. So there's two ways I can enable this next option. I can come down to my options tab by pressing N in my shader editor, then under settings, changing it from bump only to either displacement only or displacement and bump. Keep in mind, displacement only will have a better quality displacement, but you might need to do displacement and bump if you're using a combination of both bump effects and displacement effects. For now we'll use displacement only. You can see our cube is gone all obscure, and that's because unlike bump nodes, displacement doesn't alter normal information, but rather it alters the vertices themselves. And since we've only got a limited amount of vertices here, it's not exactly going to work. So how can we go about fixing this? Well, the first thing we need to do is in our render properties, under render engine, we're going to make sure we're in cycles, since this will not work in Eevee. Then I'm going to change my feature set to experimental. The reason I'm doing this is because I'm going to add the subdivision surface node, and I will need to set to experimental to give us the option of an additional subdivision surface option. Then I'm going to, with my cube selected, left click on my wrench. I'm also going to go back into object mode. I'm going to add modifier, and I'm going to choose subdivision surface. Change it to simple, and I'm going to choose adapted subdivision. Straight away you can see that something has changed. I'm going to change my dicing scale to 0.2, and I'll change my levels viewport a little bit higher. Now things are starting to work, but things are a little bit crazy here. One thing I can do here is set my mid-level to 1, and this will bring things back to normal for our cube. You can see that the difference between this and bump is quite significant since there's a lot more detail, and this is why displacement looks absolutely awesome. If you're noticing there's a lot of jagged lines, that can be fixed by increasing the levels viewport here, as well as turning the dicing scale down, and you can also, in object mode, right click and left click shade auto smooth if you have it, or if you don't have that option, just left click shade smooth. Then under our green triangle, under normals, turn on auto smooth, just to make sure we're not shade smoothing anything that shouldn't be shade smooth. What about scale then? Well, scale affects the size of the displacement itself. So if I was to set this to 3 for example, you can see things have gone pretty wild here. I'll return my scale back to 1. So is there any other way we can do displacement? And yes, there is, but this isn't done in the shader editor. So what I'm going to do is go ahead and press X on my material just to remove it. Then I'm going to delete my subdivision surface modifier, and I'm going to change back to supported, since we don't need our feature set to be set to experimental now. Now under our wrench here, I'm going to press add modifier and choose displace, and I'm going to press plus new on this texture option here. You can notice our cube size has changed, and we can fix that by just changing our mid-level to 0. But for now I'm going to leave it at 0.5. Then I'm going to come down to this tab at the bottom here, which will allow us to edit our displacement texture. There'll be a setting here called image, and we've actually already added our height map into our scene, but if you don't have it, you can just press open and find it. So I'll put that in there, but we're actually facing a similar issue that we had before, and that's that we don't have enough vertices to work with. So I'm going to go ahead and add another subdivision surface, and I'm going to move this one for our displacement modifier. I'll change it to simple, then I'm just going to go ahead and keep altering this levels viewport. But there's still a bit of an issue. Things are looking really weird here. I'm also going to set my mid-level to 1, but you can notice we've still got a lot of issues here, and that's because we're using our local coordinates where we should be using our UV coordinates. And now you can see we're now got this result. If you're still not happy with things, you can experiment either altering the strength to something lower, or you can go ahead and add an additional subdivision surface modifier. You can notice now that I've moved that second subdivision surface modifier to the top, it's now looking a lot smoother. If you don't want to have loads of subdivision surface modifiers, you can just delete this new one we've made. Then I'll go into solid view so it's less laggy. Notice how when we're using the modifier, we can see it even in other viewing modes. And I'll press tab to go into edit mode, and I'm going to press A to select everything, right click, subdivide. And let's subdivide it a few times. I'll go with 5 just now. And now you can see after after I've subdivided that, our displacement is looking a lot better. So this is the positive benefit that using the displacement modifier has. We can see this even in our solid view. Which one you prefer to use is really down to your own personal preference, but I personally have found that using the displacement modifier has been a lot faster in my computer. Another benefit of displacement modifier is I can go ahead and make these changes permanent. So the first thing I would need to do is come to my subdivision surface modifier. I'll change my render up to 6 just to be safe. Left click the drop down arrow and left click apply. This might not work in edit mode. Then I'm going to do the same thing here. I'm going to left click the drop down arrow and I can click apply. If you want this effect to be animatable, you can press apply shape key and that will allow you to animate whether or not the displacement is showing. But for now, I'm just going to press apply. Then when I press tab to go into edit mode, you can see we have a ton of vertices here. If I press 1 on the keyboard, you can see all the vertices we have here. So yeah, great job everyone. Now we're going to have a quick quiz. Number 1. Does the bump node affect the geometry of the mesh or just the normal information at a pixel level? Number 2. If you are using displacement, what options should you enable in Blender? Number 3. How can you combine multiple bumps together? I'll be answering the questions in 15 seconds from now. Number 1. Does bump node affect the geometry of the mesh or just the normal information? The bump node, since it is plugged into the normal of a shader, that means it's affecting the normals at a pixel level. Although it does use a height map and not a normal map, this height map is converted into normal information by the bump node. Using the height map and bump node can be a great alternative to the normal map node and normal map, since you can get a lot more detail. Number 2. If you are using displacement in the shader editor, what options should you enable in Blender? First thing we need to do is make sure we're in the cycles render engine, since displacement in the shader editor is a cycles only feature. Then we're going to change our feature set to experimental so we can add adaptive subdivision to our subdivision surface modifier. Then under modifiers, we'll add our modifier, select subdivision surface. We'll make sure we have our adaptive subdivision on. And the reason we're adding a subdivision surface modifier is because displacement will alter the vertices of a mesh, not the normals. So since we've only got a few vertices here, we need to add a subdivision surface so it's got more geometry to work with. I'm going to set my Dyson scale to something about 0.2 and I'll change my levels viewport up. Then finally, and most importantly, in our settings menu in our shader editor, we're going to open the drop down and change from bump only to displacement and bump or displacement. Keep in mind, displacement will yield a better quality result for displacement than bump and displacement, but you may need to use bump and displacement if you're using a combination of bump nodes and displacement nodes. Number 3. How can you combine multiple bumps together? This is really straightforward. All we need to do is plug the normal of one bump into another and make sure that the last bump node in the chain is connected to our shader. Thankfully, when we edit the parameters in one bump node, it won't alter the bump node of previous versions, since our normal information from previous nodes will be stored in a channel which won't be affected by these parameters. Great job everyone for completing this tutorial. In the next episode, we're going to be starting our final project, and to start off, we're going to make this brick texture. Thank you all so much for watching, and I also want to thank you all for 750 subscribers. It's been amazing that we've achieved this so quickly, so I want to thank you all very much for your support over the past few weeks. With that, I would like to thank you all again for watching, and I'll see you in the next video. Today we're going to be starting our final project for our Texture Basics course, but you can also use this video if you want to learn how to make this brick material. So to start off, I'm going to add a couple of objects into my scene. I'll press Shift and then A, then under Mesh I'll left click UV Sphere. The reason I'm going with the UV Sphere is it comes with a UV that works well for brick textures. Then I'm going to press Ctrl and then 1 to add a subdivision surface modifier. When you hold down Ctrl and then press a number on the keyboard, it will create a subdivision surface modifier with that number of subdivisions. So if I was to press Ctrl 2, it would create a subdivision surface modifier with 2 subdivisions here. I'll right click my object and left click Shade Smooth. Next up, I'm going to add a cube, so I'll press Shift A, under Mesh, I'll left click Cube. Press G and X to move this along, S and Y, and I'm going to press 0.5. And what that's done is it's half this cube on the Y axis. This is important for when we edit the UV, so make sure you do it at 0.5 just now. Then I'm going to press S and type in number 2. That should be big enough for now. I'll then press G and Z and I'll pull this up. Now we're going to set up our first material. So I'm going to left click on my third option here, which will take us into material preview. Then I'm going to drag up my timeline and change it from timeline to shader editor. I'll then left click plus new, and I'm going to left click material.001 and call it brick. Then I'm going to left click my other object, left click this drop down here and left click brick. And now both these objects are using the same material. Now I'm going to press Shift A on the keyboard, and under input I'm going to left click texture coordinate. Then I'm going to press Shift A, then under texture I'm going to left click brick texture. I want you to have a think about which texture coordinate we're going to use here. If you guessed UV, you are correct. If you didn't remember though, that's fine, since this was one of the exceptions to our usual rule. Since for a lot of these built-in textures, we usually use the object coordinate for a good result. Now I'll plug my color of my brick texture into the base color. Now we can see how things are looking. Now what I'm going to do is I'm going to left click and drag my top corner here, and I'm going to open my UV editor. The UV editor allows us to see the UV of our object, which is very important since we're using the UV texture coordinate here. You won't be able to see it in object mode, so we'll need to left click our object. I'm going to select the cube one first, press tab and enter edit mode. As you can see, we've got this cross shape by default, but since we're using bricks here, I'm going to want to use a cube projection. So first I'll press A to select everything, and that'll select all my vertices, faces or edges, and then I can press U and then left click cube projection. Now you can see that's looking a lot better. But you can notice that the ones on the side are thinner. It's because we half this cube. Another thing we should do is go into object mode, press Ctrl A and apply the scale. This means that this object's scale here, seen in the item menu, are all set to 1 now, whereas before it was set to X1, Z1 and Y at 0.5. I'll press N to get out of this menu, I'll press Tab to go back into edit mode. Then I'm going to press 3 on the keyboard to go into face select mode. Left click away from my cube to unselect everything. First we're going to do our left and right faces. So I'll left click this face here, and then I'll shift left click the one on the other side. We're going to want to do this separately from the top and bottom faces. Then as you can see in our UV editor here, despite these faces being smaller in the object, they're the same size as the front facing faces, even though they're half the size. As some of you might imagined, to fix this all we need to do is press A in our UV editor, S and then X to scale it across the X axis, then type in the number 0.5. Now you can see things are looking a lot better. If you want to make things look even more better, you can press A to select everything in our UV editor that we have selected, and we can drag it along to the far left. But of course we don't want it to go out the bounds, so we're going to want to left click UV, and we're going to left click constrain image to bounds. Now when we press G and X, you can notice we can't go outside the bounds, and we can also try doing it the other way, G and then X, and pull it along. You can choose which one you'd prefer. And if we want to return it to the middle, all we would need to do is press G, X, and then minus 0.25. And if it was the other way, we would have to do 0.25. I'll press Ctrl Z to undo that. Now we're going to fix the top two faces. So I've turned my overlays off just so you could see what I was doing better, but I've still got these two faces selected. To turn my overlays on and off, I just press this button here. Now I'm going to left click this top face, hold down shift and left click the bottom face. Again we've got the same problem, this UV is too big, so I'll press A, S, this time we're going to press Y and then 0.5, and if you want we can easily press G and Y and pull this up to the top, but it's up to you. I think it looks better like this though, at least on this side. So great, now we've got the UV working on our brick wall here, but what about our sphere? It looks a little bit distorted. Unfortunately we won't be able to get things perfect on the sphere, but we can make things look a little better. So we can press tab and enter edit mode, press A to select everything. You can see this is the default UV that Blender has given us. I'll press A and I'll press S and Y, and I'm going to change things a little bit so things are looking a bit more cube-like. You can just adjust it to a point you're happy with, and then you can just press tab to come back into object mode. Now that's sorted, we're going to add an easy lighting setup. So I'm going to add an environment texture, which is how we add HDRIs in Blender. In the world properties setting, I'll press plus new if I don't have a world in my scene already, otherwise you can use the same one. Make sure my strength is set to 1, and I'm going to left click this yellow circle beside color. Then I can change to environment texture, left click open, and then I'll go ahead and find my HDR file in my downloads. I've left the texture I'm using in the description below. You'll see there's no difference, and that's because we're in the material preview mode, whereas we're really going to be working in the render preview mode. Now you can see our shader showing up, but I'm going to go ahead and under film in my render properties, turn on transparent. That way we can focus on the bricks themselves. The reason I'm using cycles and not Eevee is because sometimes Eevee can be a little bit slow when processing textures. However, once the textures are processed, it works a lot faster than cycles, so do keep that in mind. So the first thing I'm going to do is left click my brick texture, then shift left click my texture coordinate, and I'm going to press Ctrl G. Some of you might be confused as to why I'm doing this. Because we're making a very big material in this tutorial, I feel like making things as compact as possible is very necessary. And then I'm going to press this arrow here to come out, and I'll left click my node group, and I'm going to call it brick color and roughness. To make things even more clear and organized, I'm going to press Ctrl J, and that's going to open up one of these boxes here. This is called a frame, and it allows us to put multiple nodes inside of things to keep things organized. Then I'm going to set the enable to brick color and roughness. You can also set a custom color if you wish, so maybe I'll set this to a red color, but you can set it to any color or name you like. Then I'm going to open up my node tree by left clicking these two nodes here. I'm going to make sure my mortar smoothness is set to 0.1. I'm going to leave all the settings at their default, but if you want to learn how some of these different settings work, you can have a look at my built-in textures tutorial or one of my PDF guides which explains brick textures. Link to both in the description below. Then I'm going to create another group in here, and this is because we're going to be reusing this exact brick node, and I want to make sure I can change it across everywhere where I'm using this brick texture. This isn't something you have to do usually, but the reason I'm doing this and why I think you should use the method I'm using here is because it will help with organization, which for tutorials like these and for fixing materials at a later date, I believe is essential. So I'll press Ctrl G, and you can see all these settings will be saved. Although I have made a brief mistake here. I meant to contain this texture coordinate within this node group. So I'll press Ctrl C, then press X to delete, left click this node button, and press Ctrl V. Then I'm going to connect my UV to my vector, and from the group input, I'm going to left click it, then under group where it says inputs, I'll left click this and press the minus button to remove it. And in my group input, I'm going to remove everything apart from the yellow circles, since I'm going to want to keep those editable outside of the node for now. Now back here, I'm going to rename my node group to, and this will be used a lot in this material. Then I'll press Shift D just so I can show you how this works. The colors we have on the surface, we can edit, and you'll notice when I edit one, it won't edit the other one. However, when I go inside the brick, if I edit one of these parameters to, let's say, 7.1 for the scale, then I come out and then I check the other one, the scale on this one will be 7.1 as well. So I'll set this back to 5, and I'll reset it to 5 on both of them. So think of it like this. Everything that's on the surface of a node group can be edited individually, whereas everything inside will edit it on all of these nodes. So you can think of it as the inside as being the inner workings of this node, and therefore it will apply the changes to all of the same node. But just like if we had two different noise textures, if we edit the parameter of one, it isn't going to edit the parameter of another. However, if we were to change the nature of the noise texture itself, which I don't think we can actually do in Blender, but just for example, if we could, it would change it for all noise texture nodes. If this is confusing, don't worry, we're going to keep going, and hopefully you can pick it up some more as we keep going. I'll press X to delete this brick here. Now we're in this node group here. I'm going to create 3 new inputs. The first one I'm going to call brick 1, and the second one I'll call brick 2. Then the final one I will call mortar. And this is how we're going to control our color from the main shader editor. But you can see there's a bit of a problem. These sockets are grey, which means they'll convert this yellow information into grey information, which isn't what we want. But for now, let's connect up color 1 to brick 1, color 2 to brick 2, and mortar to mortar. Now we're going to select one of these here and change it the type from float to color. And I'm going to do the same for all of these. And you can see they're now all turning yellow. Then I'll press this arrow here to go up. Now we can go ahead and create a color. For my first color, I'm going to create a much brighter color. I'm going to go for a purplish red. Around here should do for now. Then for my brick 2, increase the brightness again. And I'm going to have a more mellow red here. I'll go to my brick 1 and I'll make it quite a bit darker. I'm also going to change my mortar to completely white, since I want the bits in between my brick to be this white color. I've tweaked around with my color a lot, and I think I'm happy with how these are looking here. So for brick 1, I'm using this hex value here, which is 64171F, and for brick 2, the hex value I'm using is BF4C51. So you can use those if you want to get the exact same color as me, although I may adjust things a little bit later. And for the mortar, we've just got completely white. Next up, we need to add an additional output, and this output is going to be our roughness. So I'll scroll down in my group menu here, and I'm going to press plus on the output. I'm going to rename color to base color, and I'm going to change output to roughness. Now I'm going to preview my factor, which is a node Wrangler feature, which we covered earlier in the tutorial. If you don't have this enabled, you can just watch just now. Under factor, you can see we've got this permanent black and white mask, and this will not be changed by the color of our brick texture. But this alone would make it so the brick is really reflective and the mortar is really rough. Whereas we actually want to kind of have it the other way around. But an invert node wouldn't be suitable here, since we don't want it to be completely white and black, since it's way too much contrast. So I'll press Shift A, and I'm going to search for Mix RGB. I want you to have a guess what we're going to use this factor as. See if you can remember the word I'm looking for. If you guessed mask, you're correct. We are going to be using this factor as a mask. Now I'm going to plug my color back into the temp viewer just so we can see it. And you can see things are completely white. The reason this has turned out like this is because we've set black, which is color 1, to be this grey color, and the white is the exact same. So since color 1 is black, you notice if I turn it to black, we get what looks like our original mask. But we were wanting these black parts to be more rough than the mortar. So I'm going to go around just over halfway, although we may adjust this later. Then for color 2, I'm going to bring this down to much more grey. Then I'm going to plug this color into the roughness, and now I'll go up. Then I'll move my principal BSDF, and I'm just going to get rid of this temp viewer here. Then I'm going to take my roughness and plug it into the roughness of my shader, and then I'll plug my BSDF into the surface. Now we have some roughness variety on our bricks. Now to finish off here, we're going to make our bump. The first bump we'll be using even when we're using displacement, and this is going to act as our surface imperfections. So first what I'm going to do is press Shift A, and I'm going to come to group. Then I'll left click brick, and now we've got this brick that we made earlier. This brick texture is different from the standard one because we can edit the parameters inside to affect all of the other brick nodes. Then we can press Shift A, and I'm going to search for a mix RGB. Then I'll plug my factor, which was that black and white mask, into the factor of my mix RGB. I'm going to use this to add surface imperfection to black, the first one, color 1, which will be the bricks themselves, and color 2, which is representing the mortar here. I'm going to left click my brick, shift left click my mix RGB, and press Ctrl G. And now we've got it into a group. I'm going to go ahead and plug my color into the output. And since this is black and white, if you want, you can change this type to float. Then I'm going to call this height. Now, how would we go about adding our imperfections? Well, a great node we can use is the noise texture. So I'll press Shift A, and under texture, I'll left click noise texture. And I'm going to press Shift D to duplicate it, and I'll press Shift A. Under input, I'm going to left click texture coordinate. I'll plug my object this time, since noise texture works really well with object. What object does is spreads the texture around the object relatively evenly. Then we can plug our factor into color 2 and the other factor into color 1. But right now we can't see any of the changes we're making. So I'm going to come out of this. I'm going to change this node group to imperfection height. Press Shift A. I'm going to search for bump. I'll plug my imperfection height into the height and normal into the normal. Now you can see the change that's made. I'm going to change these roughness values to 1 so we get the full effect of the detail parameter. Second one, I'm going to set to something high like 10. Remember, this second one here is going to be for our mortar, and the first one will be for our main bricks. I'm going to change my scale to something like 50, and I'm going to set my mortar to maybe 10 since I want it to be a little bit bigger on the mortar. Then I'm going to press this arrow to go up. I'm also going to turn my strength down to 0.05. Now you can see we've got our subtle imperfection. Now if we wanted to make this look more intense, you could easily increase this value to something like 0.3, 0.4, or maybe even higher than that. It's really up to you. Next up, we're going to do the bump version of the brick and mortar protrusions. So I'll press Shift A, and I'm going to search for another bump. I'm going to plug this in between these two normals here. Remember, since this is being stored in a normal channel, even if I just change the strength on this bump here, it won't affect the previous bump. Then I'm going to press Shift A, then under group, I'll left click brick, and I'll plug my factor into the height. You're going to see it's the wrong way around. And so you can see this subtle bump effect is making it so the mortar is being pushed out, which is not what we want. To fix this, we could either use an invert node, or more simply, we can just press invert on this bump node here. And now you can see our bricks are protruding outwards. In my project file, which I have linked below, I've made a displacement which makes use of the shader displacement. However, this won't work on a lot of people's computers, and even struggles on mine. So we're going to be using the displacement modifier instead. But for that, we're going to need to bake a displacement map. So to do that, we're going to want to bake our height, but we have a problem. It's being inverted, but it's being inverted by the bump node, which won't be much help to us since we don't bake the height map through the bump node, rather we bake it through the emission. So I'm going to make sure on my principled shader here that my emission strength is set to 1. Then I'm going to unplug my height here and plug it into the emission. This will look really weird just now, but don't worry, this is just for baking. Making sure we're in cycles, I'm going to change my viewport to solid mode just to keep things nice and fast. And in render, I'm going to set my max samples to 10 since we don't need loads of render samples for baking. Then I'm going to uncheck this invert option here since we're not going to be using it from now on. And I'll press Shift A. Then under color, you can left click invert or you can search it. I'll plug it here, and now what's happening is this invert node is flipping things. And since white represents the value 1, that means that the bricks themselves will now be white instead of black. So they'll be protruding outwards. And this does the exact same thing as the invert checkbox on the bump. But we need to use an invert node to bake the texture since we're doing it with the emission. Then I'm going to come under the bake tab in my render properties and change it from combined to emit. Now I'll press Shift A, I'm going to add a texture and I'll left click image texture. I'll then press plus new and I'm going to left click this, drag it down quickly and type in Shift 8, which will give us the star sign, and then 4 since we want this to be a 4K texture. And now you can see it's changed it to 4096. Keep in mind the lower quality the image, the poorer the quality of displacement map we're going to have, but 4K should be more than enough. I'll press OK, and if you see my viewport here, it's gone black. That's because I have in this drop down here color set to texture, where by default it's set to material. You can use this if you want, but you don't have to. I'm going to keep it on texture so we can see what our map will look like, since texture will display the image texture even if it's not connected. This is obviously only for the solid view though, and if any of that sounded confusing, you can easily just erase it from your brain and learn it at a different day. Then I'm going to change my color space to non-color, since height maps, displacement maps and bump maps, which is what this is, we'll use non-color color space. I'm then going to rename it to displacement brick map. I'll save my file by pressing Ctrl S. Now before we bake, we're going to need to add a plane, so I'll press Shift A, left click plane, G and X, then I'll click this drop down and left click brick. The reason we're adding a plane is to make sure we bake the entire texture, since the default UV will just be one big square. It's also worth noting that, remember, this brick node here inside is using a UV texture coordinate. So if you're doing anything different from what I'm doing here and you're having issues, it may be because you haven't set the texture coordinate up here. Then I'll left click my displacement brick map and I'll left click bake. Alright, so the baking is now finished. You may find that it will stay on 100% for a solid 5 minutes, but that seems to be a pretty normal occurrence, at least when I'm doing 4K textures. So from here we have a couple of options. We could do displacement in the shader editor, which we could have actually done without a displacement map, but we're not going to do that today for 2 reasons. 1, it's really slow on my computer when I'm recording, and 2, most computers struggle to handle it. Another thing to note is the alternative method, which is using the displacement modifier, works in Eevee as well, so that is a big positive. So I'm going to go ahead and press X to delete this plane here. I'm going to left click my wall first, and I'm going to come into my render preview. I'm going to unplug my emission here, so I'm just going to plug my bump into here and delete this bump since I'm not using it. I'll save these 2 nodes for later just in case. Then I'm going to left click on my spanner icon, which is our modifier properties menu, and I'll left click displace. I'll turn my mid level to 1 just to bring my cube back to its normal size, and I'll press plus new. Then under this texture window here in image, I'm going to choose this drop down and choose displacement brick map. Another thing I'm going to need to do is save my image. This is really important since it won't be packed into the Blender file by default. So I'll left click image with a star beside it and left click save as, and you can choose a location to save it. Awesome. Now I've saved my map. I'm going to check my settings. We can see it's still using non-color space, which is perfect. And I'm going to left click on my spanner icon again, and I'm going to change my coordinates to UV. This will now use the UV of our object. Then I'll turn down my mid level to 0. But you'll notice there's a problem. Our displacement clearly hasn't worked, and the reason that is because displacement edits geometry or vertices, not normals. So I'll need to add a modifier and add a subdivision surface. I'm going to set mine to simple, and I'm going to move it on top of my displacement modifier. So to do that, I'll left click this drop down and left click move to first, and I'm going to turn up my levels viewport to, let's say, 5 for now, and it looks like we're going to need to change our mid level to 1. Now a problem we will encounter here is we don't have enough geometry, and there's 2 ways we can fix this. First way is we can add a second subdivision surface modifier. So I'll turn this up to the max, which is 6, then add modifier, subdivision surface, then I'll move it to the top, change it to simple, and we can increase this until we're happy with the result. And we also might need to turn down our strength, so for here I've gone for something like 0.05, might even go a bit lower. 0.03 seems to give a nice result for now. Before we go back into our render preview, I'm going to do the same thing on our UV sphere. So I'll left click my UV sphere. Also make sure all your subdivision surface modifiers have the levels viewport the same as render. I'm going to left click on my UV sphere and I'm going to press add modifier and I'm going to choose displace. Then we can simply choose our texture again, change our coordinate to UV, and leaving it at Catmull Clark 5 seems to do a good job so far. We can increase the level to 1 just to bring it back down to its normal size, and we can put the strength to something like 0.03 as well. And there we are, that's quite nice. You can see we have some jagged bits on the top here, and we should be able to fix that by adding a bit more geometry. But for this tutorial, this is a pretty good result. Now I'll hold down Z, and I'll change back into my rendered view, and here's our result. Thank you so much for watching, everyone. In the next video, we're going to be making our decay part of our shader, so we can transition between the two. This is based off of Shigaraki's quirk from the My Hero Academia, so hope you will enjoy that video. With that though, I would like to congratulate you for making it all the way to episode 11 in this course. We have 2 more episodes and then we're finished. Thank you all so much for watching, and I'll see you in the next video. Take care. Today, we're going to be finishing our final project in this Texture Basics course. If you didn't make the brick material in the last tutorial, you can either watch that video, which you can find in the description, or you can download the project file we made last episode in the description below. With that though, let's get started. So the first thing I'm going to do is turn off our subdivision surface modifiers temporarily. The reason I'm doing this is because it's going to be way too laggy for us to see the changes we're making before all this subdivision surface going on. So I'll first left click my brick wall, and I'm going to left click this option here that looks like a monitor. This is the option for display in viewport. So when I turn this off, you can see right away one of the subdivision surface modifiers has been removed. However, when we render our final image, it will still be displayed. We're going to turn these back on in a bit anyway, but for now I'm going to turn them off so we have a smoother blender. I'm going to do the same thing for the UV sphere. I'll left click it. I'll also turn off my displace for my brick wall as well. And there we go. Now when I go into my render preview, things will now be a lot faster. For now, I'm going to go back into solid view. If you're wondering why there's a texture in here, this is because I have the texture mode enabled in solid view, so it's displaying our displacement texture. I'm going to turn that off and put it back to material. I'll press Shift A in my shader editor, and I'm going to add another principal BSDF shader. This one is going to be our decay shader. Have a think about what shader we're going to need to use to combine these two together. Since we're going to be switching between the two, we're going to want to use a mix shader. So I'll press Shift A, then under shader, I'm going to left click mix shader. Then I'll plug it in between my principal BSDF for material output, and I'll plug my second shader in here. For the base color, I'm just going to make it grey for now. We're going to use a more detailed color option in a minute, but first I want to show you how exactly this mix shader is working. I'll left click this here to go into my material preview. Right now you can see that our brick texture is looking a little bit grey, and that's because we're right in the middle here with a mix shader. If I was to turn this all the way down to 0, you can see we've got the full effect of the brick texture, and if I turn this to 1, we've now got the full effect of our decay shader, which for now is just a simple grey material. So I'm going to leave my factor at 1 just now, and I'm going to work on my decay shader. So before we go in depth, we should probably organize things a bit more. So I'm going to left click and drag to select all of these nodes here. These are the nodes that make up the brick texture. Once I've got them all selected, I'll move them to the left and press Ctrl and then J. This will put them in a frame. I'm then going to left click this frame, left click the node in the toolbar, which you can open and close pressing N, and I'm going to change the label to brick shader. You can even add a color if you want by left clicking this checkbox and changing the color. Now I'm going to zoom back into my other shader. First thing we're going to want to do is sort out our base color. So I'll press Shift and then A. I'm going to search for input, and I'm going to add the texture coordinate. I'm going to use one of our built-in textures here. Then I'll press Shift A. Under texture, I'll left click noise texture. I'll plug in my object to the vector, and I'm going to plug in factor to base color. Now we've got this appearance here. I'm going to want to make our noise texture quite a bit bigger. So I'm going to set the scale from 5 to, let's say, 25. That's looking not too bad. I think I might set it to 40. There we go. You can also add some detail if you want, but keep in mind that detail does take a lot of cost of performance. So for now I'm just going to leave it. I'll press Shift and then A. Then under converter, I'll left click color ramp. I'm going to plug the color ramp between our shader and our noise texture. I'm first going to left click on the black slider and I'm going to make it quite a bit brighter. About here should do. Then for our second one, the white one, I'm going to make this one a little bit darker. And there, that should do nicely for now. For the roughness, I'm going to set it to 0.7 for now, but I might change it later. Now we're going to use the bump node to add a little bit of a cracked effect. So I'll press Shift A, then under vector, I'll left click bump. Then I'll plug my normal into the normal and I'm going to drag my texture coordinate down a little bit. Then I'll press Shift A, then under texture I'm going to left click Voronoi texture. I'm going to change it from F1 to distance to edge. I'll plug my object into the vector, then distance into the height of my bump. So this is the crackle effect we'll get by default. You can see it's closer to what we're wanting, but the problem is the cracks are a little bit too pointy, whereas we want them to be a little bit more flat in the middle. So to fix this, we can press Shift A, then under converter, I'll left click color ramp. Then I'll plug this in between my Voronoi texture and my bump. You may experience quite a bit of loading times in the material preview. I find that using cycles in the render preview is usually quite a bit faster, but it does create quite a lot of noise, which can slow down my screen capture, which is why I am doing it in material preview. I'm then just going to bring the white slider closer to the black one, and now you can see the pointy bits of these crackles are starting to flatten out. I'm happy with that just now. Now let's take a look at what things are looking like in render preview. Alright, I'm pretty happy with how our crackles are looking so far. For now I'm going to left click my brick wall and I'm going to turn on all these modifiers again. Alright, things have finished loading now. Now that we've finished our decay shader, we now need to figure out how we're going to switch between the two to create this transitioning effect between brick and decay. So the first thing I'm going to do, for the sake of improving speed, is I'm going to turn off all my modifiers again. So the first thing I've done here is just move this old displacement texture out of the way and delete it by pressing X, since that was something we used to bake in the last episode. Then I'm going to zoom out and I'm going to box select some of these nodes, pull them in a bit, pull the bump in a little bit. I accidentally checked the invert box, so just uncheck that. Then I'm going to drag and select all of these nodes and press Ctrl J. Then I'm going to change my label in the node panel. Remember, we press N to open this menu, and I'm going to call the label Decay Shader. Now I'm going to zoom in back into my mix shader, and I want you to have a think about which built-in Blender texture we can use in order to create a transition between the two. This will be acting as the mask, which is plugged into the factor. If you guessed the gradient texture, you would be correct. So I'll press Shift and then A, then under texture, I'm going to left click gradient texture. I'm going to plug my color into the surface, just so I can see what this is going to look like. I'll then go into my render preview. You can now see we've got a gradient at the end of our objects. I'm now going to press Shift A, then I'm going to come to input and left click texture coordinate object. Now you can see it's taken it to around halfway through our object. I'm going to left click color ramp. I'll plug my color ramp between my gradient texture and my material output. Now we're going to go ahead and make the gradient a little bit bigger. So to do that, I'm going to change from linear to ease in my color ramp, and we can even change our gradient texture to easing as well. Now I'm going to press Shift A, then I'm going to search for mapping. I'll left click the mapping node and I'm going to plug it in between my texture coordinate and gradient texture. Now I've done that, I'm going to plug this gradient texture into my factor, and it's going to start from black, which will represent our first shader, which is the brick shader, and it will transition into white, which will represent our second shader, which is our decay shader. But how do we get this transition to work? Well, to do that, we're going to need to make a quick animation. So I'll go back into my material preview and I'm going to change my UV editor to the timeline. I'm going to make this animation around 6 seconds long. So I'm going to go all the way to frame 1 and I'm going to set my X location to -2, which will completely show our brick shader, and I'll press I, and that's going to add the keyframe at this frame. Then I'm going to go along to frame 180 and I'm going to set the X location to 3 and I'll press I again. And now you can see if I play the animation, is transitioning between the two. Now for some of you, you might want to use a bump node instead of displacement, so I'm going to quickly show you how we can set that up. First thing I'll do is press Shift A, left click search and search for bump. Oh, I forgot to mention, the reason why I've set the end of the animation to 180 frames is because I'm using 30 frames per second. So just left click your output properties and set it to 30 frames per second in the frame rate. If you want to learn how to render out this animation when we finish it, you can check out this video in the top right hand corner just now. Then I'm going to plug my bump in between the bump and the brick shader. I'm going to go back into solid view just to see what what I'm doing. Then I'm going to plug my factor into the height and left click invert, since by default the brick mask will be the wrong way around and it will make the indentations pop out, whereas we want the bricks themselves to be popping out, so we'll turn on that invert. Then I'm going to left click my bump node, shift left click my brick, press Ctrl C, Ctrl V to paste. Then I'm going to drag this along into my decay shader. I'll then take this bump and plug it in between the two of these nodes here. So I'll plug the normal of my other bump into here and the second normal into the normal. Then when I go into my render preview, although it's not as strong, you can see we've got a brick bump effect. This can be an alternative to using the displacement, but the displacement will look a lot better. If we want to simply turn this off, then we can just set our strength here to 0, and we can set the strength to 0 on the other one. And yeah, you don't need to worry about these bump nodes affecting the previous ones, because the previous bump nodes are being stored in the normal channel, which won't be affected by any of these parameters above normal. Now I've done that, I'm just going to left click my brick wall, left click my spanner icon, and I'm going to turn on all my modifiers again. But I'm going to do this in solid view just to speed up time. Now I've left clicked all those monitor icons, which is the icon for turn on in the 3D viewport. We can go ahead and see what our final result will look like. And there we have it. That's our transition between those two shaders working nicely. You'll notice it is a little bit different from the animation that I've made, and that's because I've done mine in a different file and I made this one from scratch. So if you want it to look more like mine, you can just go ahead and tweak the brick colors a little bit. With that though, I'd like to thank you all so much for watching. In the next video, the final part of the course, we're going to cover how we can save some of our custom made shaders like the brick shader and the decay shader into nodes which we can access in any Blender menu. With that though, I want to congratulate you for completing the final project of this course, and I'll see you in the next video. Take care. So now we want to go ahead and save these shaders so that we can access them in any Blender file. So let me go ahead and show you how to do that. First thing I'm going to do is save my file, and then I'm going to go into Edit, left click Preferences, left click Add-ons, search for Node, and I'm going to make sure the Node Presets add-on is enabled. This is built into Blender, so you don't need to worry about downloading anything. Then I'll left click these three bars and left click Save Preferences. I'll exit Blender Preferences to close it, and now we can go ahead and start turning these into group nodes. So I'm going to go into my solid view and I'm going to turn off all of my modifiers just to speed things up. If you don't have this final project, you can follow along with the last tutorial. Now we can literally save anything as a preset node, so we could even save this gradient here or any of these shaders or the whole shader in its entirety, but I'm going to show you just how to save a few of these just now. I'm going to left click my principal BSDF and I'm going to shift left click all these nodes within this decay shader. I'll press Ctrl G and I'm going to come out, and now you can see this has all been reduced into one node. We can go ahead and we can call this decay shader. We might want to have some control over the inside components of this shader, so I'm going to output the strength of the bump so we can turn on the bump when we want to. Another thing you might want to control is the scale of the Voronoi texture, so I'll plug that into the group input, and I might as well plug the noise texture input in as well, and just for luck we can add in the roughness too. So it's good that we've plugged all those in, but we need to name them so we know what we're changing outside of the group node. So the first one I'm going to change to brick bump strength. For the second one I'm going to change this to Voronoi strength, or you can call it crack strength if it's easier for you to remember. Then I'll set the next one to noise strength, and we can leave this last one as roughness. Then when I go up, you can see we've got our shader here, and you can see it says BSDF, and that just stands for Bidirectional Scattering Distributing Function. Now let's do the same for a couple of these nodes just to get some more practice. So I'll left click this node here, and I'm going to shift select all of these. This here is what we use to make our gradient texture to switch between our brick shader and our decay shader. If you're confused as to what any of these things are, you can watch the previous episode to get a better understanding, but if you're just wanting to learn how to save a certain amount of nodes as a preset in the add menu of the shader editor, then you can just keep watching. I'm going to left click this and call it gradient. I'm going to take this location and take it out to the input, since that was the thing we were animating, and I'll come out, and that's just finished this node as well. You will need to animate it again though, since it's now acting as an input, but we're not actually using this file anymore, we're just using it to group all these nodes together. Finally, I'm going to go ahead and group all these together, so I'll drag and and select all these and press Ctrl G. Then I'm going to take my strength of my brick bump, move it to there, and I might take the strength of my other bump just in case I want to edit that as well. I'm going to name the first one to brick bump strength. Then I'll rename the other one to imperfection bump strength. Then I'm just going to plug in my brick 1, brick 2 and mortar into my group input so we can change them from outside. I'll left click this arrow to go up, and now you can see we've got our free shaders. Now if you want these changes to be made permanent in your file, you can just save, but some of you will probably want to save as just to make sure these changes aren't permanent. So you can either save as or press save. I don't mind, so I'm just going to press save. It's probably wise to name this to brick shader, so I just left click this here and typed in brick shader. So I'll save my file, and I'm going to left click plus new to create a new file. I'll press A to select everything and X to delete, and I'm just going to make my workspace a little bit clearer. I'll press Shift A and I'll left click a cube just so I can create a new material, and I'm just going to delete all those. I'll press edit, then I'm going to left click preferences, and in the add-ons tab I'll search for node and make sure node presets is ticked. Then I'll left click the three bars and left click save preferences. Fortunately this add-on is free and built into Blender, so you don't need to worry about downloading anything separate. Then I'm going to press file, append, then once I find my file that I just saved, I'll double click it to open it, then I'm going to double left click material, and I'm just going to add this brick material. You can also add in the node groups separately. I'll delete my material here and I'll open brick. I'll go ahead and delete this mix shader and material output by shift left clicking them and pressing X. So all we have to do now is save this file to a special location in the preferences so Blender knows where to find these shaders. So I'll press edit, open preferences, then under our node presets, which we can search for in add-ons, I'll open this up and you can see there's a directory here. But before we can even do that, we need to save our file. So I'll left click file, save, then I'm going to create a new folder and I'll call it node presets, just so it's nice and easy to find. And I'll open this up and I'll save this as node presets and press save Blender file. Then I'll left click edit, left click preferences, then in add-ons I'll search for node, open up this node presets drop down, making sure it's enabled, and in the directory node groups we're going to find our node presets folder, double click it to open it, and left click accept. Then we can left click the three bars and left click save preferences. Then when I close this, I'll press Shift A. Then under template, you can see we've got a bunch of presets here. You can see there's a few other ones from the three we have here, and that's because these nodes have node groups inside them. I'll press file and then save, then file and then new, and then general. So the good thing about this add-on is whenever you change things in that file, like you might want to add more node groups, it will update it automatically as long as you save it. But if you have any issues, you can easily just choose the file location again. You can also use the free guide accompanied with this tutorial to refer to whenever you get stuck. I'll press Shift A, then I'll just left click a plane or something like that, and I'm just going to change the studio mode, press plus new, and now in our example material, if I wanted to add our brick shader, I'll just press Shift A, then under template, I'll left click brick shader. So now we can access the shader in any file we want, old or new, and I'll plug in my BSDF to the surface here, and now we've got a working shader inside of a completely new Blender file. So yeah, that's pretty much it. I want to thank you so much for watching, and a massive thank you for everyone who's been following this course. It has been a massive difference in my channel. We've gone from under 500 subs to just over 900 subs in just over a month. So I want to thank you all so much for your support. If you enjoyed this course, make sure to let me know, and you can also provide any questions, suggestions, criticisms, or anything you would like. It's all very much appreciated. Thank you all again for your support and for watching, and I'll see you all in the next tutorial. Take care.